Yeah, I think in the paucity of time, we will start. So good morning, everyone. So good morning, everyone. Fantastic. Just one sec as they are fixing. So my name is Ahmed. I'm part of the organizing team here at Zak. So we are organizing the Zak World of Façades conference series for the first time in Tirana. But in the global series, which I will show you, this is our 50th country. We finished around 215 editions in the last 14, 15 years, all doing one event on facades. So you have people only talking about the external building envelope and nothing else. It's the most beautiful part of the building, but the most ignored part. And facade engineering itself as a profession is a relatively new profession. So you'll be hearing from a lot of facade engineers today, who we have brought from other parts of the world, from the UK, from Spain, from Italy, from Belgium, from France, from Italy. So it's going to be an interesting event. And we also have architects who are designing for projects here, who have already built projects here, also talking on the building envelope. Otherwise, you have a lot of talk about master planning and other things, but I think today's focus is completely going to be the facade and the building envelope. I'll quickly introduce the event to you guys, and then we'll get into the program. I'll take 7-10 minutes till we warm up and we get people coming into the hall. So this is our calendar of events for 2026. We have events all across the globe. Albania, again, is the newest one, country number 50 for us. I didn't hear of Albania at least the last few years ago, when Dua Lipa became a big sensation. And then Albania literally came in the map for people like me from a different part of the world. And then the architectural scene exploded in Albania. You have some fantastic projects which are happening here by international architects, by the local architects here. So I think it's one of the crown jewels probably in this part of the world. I think if all goes well, if the projects are built as per what they have been announced, I think you're going to have Albania having more projects than most of Western Europe, at least in the high-rise category. So today's agenda is a reflection of that. We have people who are basically doing work here, who have done work here, and are going to be doing work here. So you have different perspectives of people who have already built here, going to build, and also from facade engineers who are actually working here and who are also planning to work in this market. So it's a very interesting agenda. Events are from New Zealand up until Canada. I don't have a New Zealand on this calendar, do New Zealand event on this calendar here. We do New Zealand once in 2 years, but we have events from New Zealand up until Canada. And the way facades are designed, engineered, installed in every region is different. I think North America, most of Western Europe is more adaptive reuse, renovation, recladding projects, heavy on sustainability, on carbon. The Middle East is on another level, you know, giga projects, all 500 meter, 600, 700 meter towers, you know, complex structures. So the agenda is curated for those respective regions. I think Albania, being very close to Europe, has a lot of influence on sustainability and on a lot of things which Europe practices. So you will see that in today's presentations from our speakers. And yeah, so this is our calendar of events for 2026. Everything was looking normal till we had the war in the Middle East. So our Dubai event of last week got postponed, but we hope to do it soon. We're very strong in North America. We have almost 9 events in the North American region. 2 other places which we went last year and we actually repeated is Uzbekistan and Georgia. Again, 2 places which surprised us. Lots of projects happening over there. A lot of European architects and engineers working over there. India, where I am from, we've always been strong. We started this event back in 2012 in India, and then we were able to grow this to other countries. Of course, Italy, we've been in Milan a couple of times, and we're going to be doing Rome next week, which is again a very different market from the other parts of Italy. It's a completely adaptive reuse, renovation projects mainly there. So the agenda keeps changing. Our biggest in the series are London and New York, which are London's over 1,200 delegates attending, so that's our largest in the series. So yeah, so this is what we keep doing. I just wanted to give a brief overview of what we do, and it's just one topic, facade engineering. We've got seats there if you want to. We've got seats, plenty of seats here if you guys want to. Somebody can help them. Yeah. So this is what we do with the events. And of course, these events are courtesy our event partners. We have 15 of them today. I'll just introduce all of them. They all have a tabletop display, so please meet them in the course of the day. We have 2 breaks. We have 3 sessions and 2 breaks we have. And then we have post-event, we have a networking reception cocktail. So you can meet them across. Just to let you know, the tea coffees are served at the 2 terraces outside. One is over there, the larger one, a smaller one over here. Lunch will be served down, 1 level down, level 2. Near the escalators, elevators, you have steps which are going down. So lunch will be served over there, but all the tea, coffee will be served in the 2 terraces over here. Our presenting partner, Alukonikstahl. Alukonikstahl is a strong partner of Schuko. They are the official representatives of Schuko in the Balkan and a few other regions in Europe. And for those who don't know Schuko is a global leader in aluminum door, window, curtain wall systems. And Alukonikstahl are their partners. Alukonikstahl are also distributors of Varema and Janssen. Varema is into shading and Janssen is into steel door, window and facade systems. So they are our presenting partner for this event. They have the largest stand outside, so you definitely can't miss them. So our presenting partners are Alukonikstahl and Schuko. We'll start with our associate partners. We've got 14 of them. AGC. So AGC is a global leader in coated glass solution. Part of the wider group of AGC, you have fire rated glass, you have LED glass, dynamic glass and other stuff. But AGC is a big glass manufacturer with coated glass and other high performance glass solutions. Alucoil is from Spain. Alucoil has non-combustible cladding products. It's an aluminum composite-based solution, but they have a non-combustible range, and they have several reference projects here in Tirana, in Albania too. Aluflor America is from Albania, but they're working here and in the US. They are into facade engineering solutions in terms of installation and fabrication of doors, windows, and curtain wall products. They are another associate partner of ours. Bostik is a global leader in sealing and bonding solutions. So Bostik are into the insulated glass segment, into the rear ventilated cladding fixing segment with their tapes and their bonding solutions. So that's Bostik. Elvalkala is from Greece, one of the global leaders in, again, non-combustible aluminum composite solutions. They have a couple of products for interiors and other cladding for interior applications. Favemank is part of the Gressmank group. They have a extruded terracotta ceramic solution. So terracotta is another popular product, age-old product. So they have an extruded terracotta which they promote under the Favemank brand. Front is from Kosovo. So they are a distributor of several cladding products from fiber cement, from high pressure laminates. Fiber cement partner is Swiss Pearl, high pressure laminate is Fundamax, and they have several other products. They're also launching their new GRC factory, which I'm being told is going to be the first GRC factory in this region. GIG is from Austria. They are a facade engineering company. They do fabrication, installation of doors, windows, and curtain wall. So they are exhibiting with us for the first time. iBuild is from Greece. So iBuild does glass processing as well as fire-rated solutions. They have project references globally. They are another associate partner of ours. Kurare is a Japanese company. It's the mother company of the laminated glass Intellias, Trocifol, and Sentry glass. So you need to have laminated glass. There are different types of laminated glass which you'll hear from them, and Curare is the world leader in their interlayer products of Trocifol and Sentry glass. Martini, again, a local company from here, Facade Engineering Solutions, fabrication, installation of doors, windows, and curtain wall. So they are our they are another associate partner of ours. Orlando Engineering is an Israeli-Estonian company. They do engineering services. So if you want to get your facade engineered, if you want your shop drawings and anything else to be done, Orlando Engineering is the company to look forward to seeing. Kricursa is one of the world leaders in curved glass solutions. They are now part of the TVTech group. So it's TVTech Kricursa. They are from Barcelona in Spain, and they have provided curved glass for some of the leading projects around the world. Majority of the Apple stores, if you have visited in other parts of the globe, you would see a Kricursa glass in it. So they are another associate partners of ours. Was Glass is a value-added high performance glass processor out of Greece. They have several realized projects here in Tirana, working with different investors and fabricators. So they are another associate partners of ours. Our media partner is PicArc, again a local publication here, along with Glass Balkan. So Glass Balkan, Tahir, I think, has been pushing for us to come to Albania from a while. So thanks to Tahir is one of the reasons why we are actually here. And of course, our next event, as I said, is in Rome next week. In the extended European region, we've got Rotterdam, which is next month. We've got Manchester. Of course, lots of events in between in North America. I'm not showing them. Limassol. So we did Greece last year. I think Greece was fabulous for us. So we decided to go to Cyprus. Again, Cyprus is country number 52 for us. And no facade engineering conferences happened over there. So which is again something which is going to be exciting for the local architectural community there. And Lisbon, we returned to Lisbon. Lisbon's our second time. We did 1-2 years ago. Was excellent. So we returned to Lisbon. So this is what we do with respect to the events. We get architects, engineers, investors, general contractors, facade contractors all together and talk about the building envelope. The program is structured that way. You have a lot of people talking on different topics. In case you miss any of the presentations, you need not worry. We have recorded this event, and if we have permission to share that presentation with you, you'll get a YouTube link, which you can then view the recordings. The YouTube link should reach you 7 to 10 days upon completion of this event. So that's it from me. I think I've taken too much of time, but we have a full hall now. So we have seats here if you'd like to get seated over here. So please, you can make your way here. Jona Osmani, she's the General Director of Territorial Development and Control for the Municipality of Tirana. So she's going to be a host for today. Maybe if I didn't mention, yeah, I didn't. We have simultaneous translation headsets. 90%, 95% of our content is going to be presented in English or maybe full, I don't know. In case you need simultaneous translation headsets, they are kept on the table over there. I hope you enjoy today's event. It's a very exciting program we have. I've had a sneak peek of the presentation, so I think you're in for a treat. So thank you all for taking your time and coming. We hope you enjoy today's event. And over to you, Jona, to take this forward. Thank you.
Well, thank you, Ahad, for the introduction and the warm welcome. Good morning, everyone. Firstly, I would like to introduce myself for the ones that are new in Albania, even though I see so many familiar faces. I am serving as a General Director of Urban Planning and Territorial Development Control at the Municipality of Tirana. We are engaging in several projects regarding urban regeneration, building rehabilitation, and also one of the, let's say, most important and very close to my heart initiatives, which is the Urban Renewal 2.0. And for me, today being here in Tirana is an honor, actually. And being here with many of my colleagues is also a great pleasure. because facades for us, architects especially, they are not just skins, but they are also the face that the city shows to the others, to visitors, and to the residents that live here. Um, I would like to start with the first session on the topic of facade approach to design process. And I would like to give a warm welcome to Silvia Ilardi, Senior Architect at Facade Access and Maintenance, Arup, Sofía Galán Rivera, Building Envelope Design Leader at Arup, and Pat Duffy, Associate of Facades at Arup. Thank you.
Thank you.
Hi, everyone. My name is Pat Duffy, and I'm an Associate Director with the Arup Facade team. I'm based in Dublin. I have been working on Albanian projects for a number of years now. In a slight change to the normal Zak format, myself and my two colleagues, Sofía from Madrid and Silvia from the Milan office, are presenting 3 10-minute bursts to describe the Arup approach to the facade design process. At this stage, on behalf of my colleagues and I'd like to thank Ahmed and the Zak team for inviting us to speak here, and promise that the change in format won't be at the expense of good timekeeping. This is what we propose to present today. I will discuss the Arup approach from a high level and how our global knowledge can be best applied to the local market. Sofía will set out how we help turn facade design into project value. And Silvia will discuss the importance of engaging with access and maintenance advice at the earliest stages of the project. Dedicated to sustainable development, Arup is a collective of designers, consultants, and experts working globally. Founded to be humane and excellent, we collaborate with our clients and partners using imagination, technology, and rigor to help shape a better world. Arup, pictured here on the right and in the centre of the picture on the left, which was taken at the construction of the Sydney Opera House, set the company up. He's a fairly iconic figure in world engineering. He founded the company in 1946 and left it in the possession of a trust for the benefit of the employees, who are the effective shareholders of the company. An ownership model which is quite unusual, but one that we are intensely proud of. The founding values, The founding values of the company are an integral part of the key speech given by Arup in 1970. In this speech, a path full of principles was traced, including total architecture and social utility, which, approaching 60 years on, still guide the activities of our company. Nowadays, we refer to total design as opposed to total architecture to reflect the changes in the makeup of design teams in the intervening years. Some key stats: 80 years old this year, over 18,000 members, turnover in excess of £2 billion sterling, 94 offices in 34 countries. In terms of our facade engineering offer, we have over 300 members located globally, working on a diverse range of projects, big and small. Albania's real estate market is currently undergoing rapid growth, driven by comparatively low construction costs and significant foreign direct investment. This foreign direct investment is being attracted substantially by the long-term development potential. The country's ambition to join the EU by 2030 further strengthens investor confidence, while also signalling the introduction of more rigorous regulatory frameworks. This momentum is generating a diverse range of projects, from high-rise towers to major master plans, transforming Tirana into a modern metropolitan centre and opening up previously underdeveloped coastal regions. In the coming years, Tirana is expected to transform with multiple 100-metre, 200-metre, and even beyond towers, and major low-rise buildings as well, into that metropolitan centre. Arup is actively engaged in this transformation, supporting major developments and international architects through multidisciplinary consultancy expertise and playing a leading role in transferring international knowledge to the local construction industry. This is not to say that there is not already impressive capability in the local Albanian market. Here are some examples of buildings recently completed in Tirana using local facade contractors and designers, some of which are here. These are people who can deliver unitized curtain walling, architecturally complex geometry, and internationally benchmarked performance that will continue, and that will continue, I've no doubt, in the next phase of the development of Tirana and Albania. In addition, the market is open to expertise from outside, and some examples are shown here. This is a really positive measure of the maturity of the market here. And as this cross-fertilization will be essential if the ambitious architectural designs that are proposed are to be realized. This will not mean that foreign contractors will swoop in and take all the high-profile projects. I would see that the expertise and technical skill and manufacturing capability of the outside contractors will be combined with the key skills of the local contractors to deliver Tier 1 projects in Albania at an appropriate price point. Accession to the EU will challenge the Albanian facade industry. However, I would not see this as from a technical standpoint. I more see it in terms of regulatory maturity, documentation discipline, and risk allocation. The contractors that invest early in facade engineering capability, certified systems, and compliance processes will not only survive, but will become regionally competitive in the EU market. The industry will move from a labour-intensive model to more of a Vorspring technique model, to borrow an advertising slogan. Our multidisciplinary teams offer comprehensive skills at global scale. Our broad geographical and discipline spread benefits all our projects, big and small. The philosophy of total design, as explained by Arup back in 1970, is still a cornerstone of our approach to engineering. For instance, we in the facade team will regularly engage with our wind engineering, fire engineering, lighting, computational fluid dynamics, building physics, access and maintenance, for example, teams, to test out our ideas during the design process. These specialist disciplines may not have a formal appointment on a project, but our proximity to the skills such as these benefits both ourselves and our clients. We are generally brought onto the Albanian projects through existing relationships with the internationally recognized architects, and our international reach and depth of experience brings confidence to developers on technically challenging projects. We do not see ourselves as displacing local teams either, but rather are involved at concept and scheme stage to contribute in a way that allows for best international principles be applied. Typically then local consultants then take over to localize the designs and bring the project through to completion. We sometimes carry out a review role through construction. The projects are based on performance design specifications, with the contractor developing their own proposals backed by calculations and drawings, etc. Finally, for me, a few examples of the projects that we are currently working on or have recently been working on. Limani Resort in the south of Albania, a coastal resort development designed by Arup Architecture. Guri Tower in Tirana, again by Arup Architects, 100-metre tall tower with really distinctive facade. And finally, Lepidopter Tower, a project that I've been working on myself in Albania as well, features a complex system of shading louvers formed in the shape of butterfly wings. Let me hand over now to Sofía, who will explain why facade engineering matters.
Thank you,
Sofía.
Why facade engineering matters? As Jona said before, facade is more than a scheme. At Arup, we don't see the facade at the boundary that separates inside from outside. We see as a system, as a critical one. Facade is where architectural, engineering, performance truly come together. It defines how a building looks, how the people is going to experience and use the building, and how much it costs to build and to maintain it. At Arup, we consider the facade as one of the most influential systems in the early design process, because it has the most or the greatest opportunities to add value in the early stage. Why facade engineer matters? Because every facade starts with people, not with details. Our approach begins by understanding what the clients need, how people will use and experience the building, and what the building will need in 10, 30, or 50 years. We listen carefully about functionality, safety, and security requirements, budget and program constraints, environmental and social ambitions. Our role is to guide our clients through the complexity, making, translating expectations into clear technical decisions. And why facade engineering matters? Because facades don't work alone. Neither do we. In a city like Tirana, where buildings are getting taller, facade systems are getting more complex, with interfaces, with structure, services, and day-to-day user experience. Through our total design approach, we integrate the facade design with architecture, with structures, with daylight, acoustic, access and maintenance, and fire requirements in the design. That lets us to test interface early, resolve problems before they become, resolve conflict before they become problems, and keep budget aligned. At the end of the day, early design, early coordination is what limits risk. And after talking about cities, people, and total design approach, the question is simple. How do we make this work in real projects? At Arup, we have a simple process: concept, performance, delivery. Not as a checklist, as a way of making good questions at the right time. Concept is about setting intent early. Performance is about test intent. And delivery is where coordination really matters, turning ideas into something that can be built and will perform over the time. Each stage limits risk. Every decision we miss in early stage usually come back later and they tend to cause more effort to fix it. And before we talk about facade designing, we have to step back and think about how the facade is performed. The performance is what shaped the building. Using parametric design, we test different decisions, and we see how they influence in the comfort, energy use, and overall performance. At concept stage, we focus on the building as a whole, its massing, its orientation, the size and the distribution of the windows. This early analysis help us to make us better questions. Where the views add more value? Can geometry reduce energy consumption? By addressing performance before the facade exists, we support our clients in making well-informed decisions. And to support these early design decisions, we use performance analysis when change is still easy. We test daylight optimization, solar exposure and shading, and mechanical performance. This gives us a clear choice early on: keep, adapt, or adjust, or compensate with complex design. That turns assumptions in measurable criteria, keeps disciplines aligned, and reduces risk of late surprises. And once we have finished with the performance, we start the next stage, the delivery. This, where intent becomes strategy. We translate performance goals into facade typologies, materials choice, and system logic, all tested through thermal and energy modeling, condensation analysis, coordination with structures, MEP, and fire. This allows us to make up informed decisions on cost, carbon, buildability, and long-term value. At this time, the facade stopped being an idea and started being a system. Once system and materials are defined, success no longer depends on big ideas. It depends on how things go together. Because facades don't fail at elevation, they fail at interfaces. In the delivery, we develop all these connections, the fixings, tolerance, and interfaces with the structures, MIP, everything. So far, this is design. The next step is making sure these drawings can actually work on site. We work closely with the local industry to ensure materials are available, fabrication is realistic, and installation can actually happen. Often supported by prototypes, samples, and visual mock-ups. So far, we have taken the facade from concept to the delivery. But this is the key point. Delivery is not the end of facade engineering. Total design means staying until the end. Designing facade is not just to be built, but to deliver value every day it uses. That's how facade engineering turns design into long-term project value. And now my colleague Silvia is going to explain how access and maintenance is really important to consider in the early design stages.
Thank you. Try to stay in the no-noise part. So, in this last part of our presentation, we will answer to the question why it's so important to consider access and maintenance at the early stage of the design. Because access and maintenance seems to be a really small piece of the puzzle in the total design approach, but exactly as all the others, it's important to make the puzzle work. We need to start to try to answer to the question why access is required. And it could be required for maintenance, components repair, cleaning, inspection, isolator or major repair, and which factors are influenced by a good access and maintenance strategy. The factors are the aesthetic of the building, the reduction and the control of the costs, the efficiency of the function of the building, the frequency of the operation, and the working at tight risk reduction in relation to the legal compliance. But why it's so important? Because besides the working at tight risks reduction, the duty as designer that has the aim of an holistic and sustainable design with we would like to keep our and client reputation good. We do our design following the health and safety principle. And the important thing is that prevention is better than cure. Safety for us is really important, but if we don't give the right strategy to the operators, they will find a solution to their access problem, but maybe it's not the safest one. We can talk about culture of safety, and the UN SDGs gave us a clear path, especially with those 3 SDGs. SDG 11, starting with the cities, talk about safe, sustainable, resilient cities. Instead, SDG 3, talking about people, talk about people well-being and health. And SDG 8 show us that it's really important to have a decent work. So the path is written. There's a lot of work to do because many times we face the sentence, we have always done in this way. But we as designers, we have the duty to do a change. And to make a change, we cannot just list the legislation, things, the regulation that we need to follow. We need to make a change in our projects. For Arup, safety is a really important topic. In fact, this topic is fundamental and is part of our global strategy, the future we choose. And here you can see a quote of our chair, Jerome Frost, who said that for us, safety is for all the Arup members. Safety is also for who construct our building, is for people who take our advice and put them in place, and ultimately for the users. So for all the people that are in this process. Here, the approach. This is the key image that shows you the approach that we apply when we design, and we start from the very beginning, optioneering the solutions with the design team. At the top of the pyramid that show the hierarchy of protection measures applied to the design, you will say the lower level of risk that we can reach avoiding working at tight, but definitely it's not always feasible, especially with tall buildings. So lowering a little bit down at level 2 and increasing a little bit the risk, if you in your project define safe place where operator can work, you are, I would say, reducing quite a lot the risk for operator. Then instead, in the second half of the pyramid, the lower part, we have all those solutions that we apply to our design to prevent falls, and at the very bottom, so the higher level of risk, to minimize the consequences of fall. So all that kind of equipment that we put in place to prevent. It's important to consider and to say that the competencies of the operator that will act on our building has to increase as we on this pyramid, because the risk is higher. And I will also highlight that for EN regulations, the principle of prevention put the collective protection measure above the personal protective measure. So the top part of the pyramid above the bottom. Now we will go through sample projects, and we will go through projects explaining the challenges that we can encounter when we design. I will start with this iconic building, the Qatar National Museum in Doha, that we developed quite a long time ago with Atelier Nouvelle. At the very beginning of the design, so at the concept stage, the building was considered and was designed as a sort of almost white building. But when we start to think about the frequency of cleaning of this building that was so clear, considering that we are in the desert, so with sandstorms or something like that, it will become dirty quite frequently. So with the design team, we ended up to vert in a little bit more sand color to reduce the frequency of access. Another important thing to consider, and another topic, is the geometry that, as you can understand, it was quite complex. So looking at the geometry of the building and crossing the volume with the outreach of the machines to access, we reduce as much as possible the area accessible by forest drain system on the roof. Now, with the next to London building, I would talk about quite important thing related to the fact that we need to think about access and maintenance, not just putting a BMU on top of the roof, but access and maintenance can influence quite a lot of part of the building. For, sorry, I haven't said the name of the project, 18 Blackfriars in London that we are developing with Foster and Partners. They are 3 towers. The center one is an office building and the other 2 are residential towers. The office building is characterized by CCF facade, so a double skin. And usually double skin for access and maintenance means, please, remember, access and maintenance is really important because you don't need to access them just from outside, but you have a second skin that requires exactly the same frequency of access. And especially when you think about glass replacement, and you cannot do glass replacement from outside, it means that the full part of the glass and the full part of the equipment required to do your glass replacement needs to be coordinated at the very early stage. Because you know, the core, the lobbies, the loading bay, they are all part of this path. And if we don't have a big enough goods lift with the right capacity, we are not able to bring the glass up. So we will have an issue during the life of the building. It will be a big issue. In the same project, we also had quite a lot of terraces with a lot of planters. Planters is another challenge that we are facing quite a lot in this last period. And for this project, we worked and we coordinate quite a lot the size of the trees, the position of the furniture to allow access and maintenance for the facade. The second London project is the Vista project that we are developing with Make, is on site now. I will quickly go through this because of building obstructions, especially for buildings that has complex shape with protrusion canopies. We always need to try to define a way to access. And especially talking about this image in the center, you can see that at the very beginning of the design, there were a group of balconies that were obstructing a full strip of the facade. So we managed to move them, because we were at the design stage, to avoid this kind of issue. This is the last project, and it's a project that we delivered in Milan and hosted the Olympic Games that we just had. It's the MSG Arena that Arup architecture developed with David Chipperfield architect, who focused on the facade. And here I would focus on the working at height reduction risks. At the very beginning of the project, the slabs were reaching the facade, allowing access only via four restraint system, as you can see on the left. But because we were there at the very beginning, we were able to integrate the access strategy, just lowering down some walkways on the perimeter of the building, allowing the operator to act with a collective protection measure. So we think that access and maintenance is really fundamental requirements for the success of the design of our building. We hope that those three quite different presentations gave you a clear understanding of the approach that Arup apply to the facade design. Thank you.
Well, thank you, Silvia, Sofía, and Pet. It was such an interesting and detailed topic about performance-based design. And now the floor belongs to Marco Casamonti, founding partner of Archea Associati. He's an architect and a well-known figure in Albania, and I believe a week ago, a resident of Tirana as well. Please, welcome on stage.
Thank you so much. My pleasure. Yes, it's true. I'm from 10 days ago, I'm a citizen of Albania. I'm very proud of this. And why? We realize a lot of buildings here, like the stadium, National Stadium, like the airport right now, like other buildings. So I ask to the government, especially the Ministry of Culture, to be part of the community. That's very important for me. I'm proud of this. And I hope that all architects that work in Tirana ask to be part of the community. That's the reason why also the facade design are so important. Why? Because the building have a private part, have a public part, and semi-public. Where is private? Private part is internally. Internal is a private part of the building. But the building from outside is a part of the community. So it's not a private investment. It's a part of all the city, all the country, and represent the country. And you can build for the private investors and a building, but you have the responsibility to create something special for the community. That's very important. And what is the part of semi-public? The lobby. The lobby, the common space inside the building is not private because all the people can go inside. So when we think about the private part, we have one kind of responsibility. Semi-public, okay. But when you build outside the building, the impact of your architecture is for everybody. So that's need to be important. So, but what I think regarding facade, I think that facade is also the most important part of the design. Why? It's a part where you create to demonstrate not only with the design, but also with the material, how much is important, the relationship with the place, with the country, with the identity culture of the country. So in each our building, the facade is so important. So this is, and we written a books with our office that we divide our architecture in terms of material, not in terms of I don't know, in terms of style, like minimalistic, maximalistic. No, I'm not any interested in this. I'm interested if the building is in glass, is in concrete, is in wood. The material having a special connection with the identity culture of the country. So when we designed this building many years ago, is in a factory that produced candles and chewing gum. It's a perfetti Vonelle factory. And we covered the facade with 40,000 candles in glasses. So what means? Means that the facade represents the identity culture of the factory and represent in certain way the idea that this factory is part of the community. Because this building is exactly in the center of the village, close to Milano, is Lainate, close to Milano. And all the citizen works in this factory. So that's interesting. And what's happened, it's we decide, okay, they produce candles. Chewing gum is the most important company worldwide in this field. And we decide to realize like a next of steel and to anchor these 40,000 candles. Was not easy. Arup have completed a reason. Was not easy. We are work like a researcher. And if you think, 20 years later, we have under design now the airport of Tirana. And I remember this project. Oh, I love this. I want to do something like this. Because the facade become like a jewelry. Represent identity culture and the identity of the factory, represent the identity culture of the village, of the city, and it's a special place. So with the glass, but we work a lot with glass, for example. This is another facade that we designed in Lugano, in Switzerland, and the client asked us, Marco, we want a marble facade. Okay, because I love marble with gold, but I hate marble. Why? Because the marble absorb the dusty. And I want marble, but it's easy to clean like glass. So in that case, this is a composite of glass. Inside the glass, there is a brass fabric. We stretch it by hand, and we put inside with a Centrigas Plus from DuPont. We insert inside. So looks like marble, gold marble, with a vein inside, but it's glass, easy to clean. So we designed this facade, and if you see, and also we want to have the variation of marble, because marble is natural product, it's not like glass, not industrial, and change the color. And we decide to retro painting in 5 different colored glasses. So become natural material, easy to clean, but in certain way create the atmosphere, reflect the trees on top. And when you work on this, you can create your material. That's the best that you can do. Okay, there is a lot of company here that they can have a standard product, but what we can do together, this very huge company, that you can produce your material, you can design your material. That's our approach. And when we design this, I want to reflect the sky. I want to have a color that is gold, brown, and in the middle, and to internally, you have the feeling that this looks like marble. So can be possible to do this? Yes, can be possible. It's not easy. You need to do research. Unfortunately, okay, if Arup have an incredible experience, you show to us. And our experience is to work like artisan, to go there, to test the material, to try if it works or not, stress the material. But the results, in my opinion, is not bad. Now, there is other way of works. This is a very famous project, it's Antinori Winery. The facade is covered by vineyard. It's a winery, they produce wine, and we cover completely the facade. Don't exist, the facade is just a roof. But the roof is covered with a 1 meter, more than 1 meter, 1 meter 500 centimeters, and we plant other vineyard on top. And we excavated a lot of a cubic meter of earth. We take the earth and we produce with the earth the bricks, with the same earth of the excavation. But the bricks was red. I don't want red, I want the color of the land. So what happens? We take the argilla is clay what is the name of argilla? I don't remember. Clay. Yeah, we take clay. We try, when the clay go in the oven, the bricks become red because there is oxide of steel inside. I don't want to have a red color. I want to have a brown color. So we try to introduce bioxide of titanium inside the clay. And when you put in the oven, the result is brown. That's good. We try to do this. It was very, very hard work. Very hard work. So 1 year to find the correct clay color after the oven. And we design how we can anchor on the roof, okay? Like we create omega and we produce these tiles like pasta. We realize the matrix and we produce like this and we insert in the steel structure. And we realize all that. Internally is the same but red because the vault that you have inside is red is good because the color of the wine. So what I want to tell you, you can design your material. You can produce your material. If you work like artisan that produce the material, touch the material, testing, it's not easy. It's a long process, but I think we have this responsibility. Okay, and we realize with terracotta, we work a lot with terracotta. Terracotta is a part of our, and also the concrete. You see the concrete is red. It's not gray. There is a pigment inside, and we want a facade that looks like rock. We sand it, so we use normal concrete with a pigment, and we sand it, and the effect of the is completely different. So this is another facade. It's in bamboo. Very simple. Very simple. This client is a village in Tuscany for tourist village. We don't have money. Unfortunately, the budget was very low. And the client asked me, Marco, we don't have any money for the facade. Oh, don't worry. We was in Africa. We bought, we visit a lot of places where we can find bamboo. We import, I don't know how many containers of bamboo, and we install this bamboo in very simple way. But which is the identity culture. So you see the pines is vertical lines, and we say, okay, you don't have money, cover everything with bamboo. The precast ugly building, this is a supermarket for food in a camp, is a village, is like a camping. But if you understand that the verticality is the identity of this place, you can work from verticality. So we can work with bamboo, very simple, very cheap material, and we cover everything. I say, you don't have money for other building? Okay, cover everything in bamboo and you solve the problem. And that's it, what's happened. So, so what I want to tell, material is not an option. It's the main parts of the building, a main part, in my opinion, of the architecture. So this is another building in terracotta. This is a library. This is a library in Italy, in north of Italy, close to Bergamo. And I told to the mayor of the city, I want that this building is covered by books. Covered by books, yes. I can realize the books in terracotta, and we glaze it with the same company of the winery. We work for them. I want to realize the books, red books in terracotta, glaze it. And we need to glaze it in 6 parts, but it's not possible because you work in the rain when you're painting. So one part, the lower part, was painting by hand, and the other glazed in the oven. But how we realize is there is a steel structure inside. Also, this is designed by us. We realize the element. We realize the steel structure is very easy. The steel structure, we take the Mies van der Rohe house pillar that they realized in Barcelona, is a cruise, and we attach the anchor and we anchor the facade. It was easy, and that's the result. So what I want to tell you, this is the library, is a house of books, and the books also cover the building. So when you are inside of the library, you are inside the book's shelter, and books move around you. So it's easy for the people to understand the character of the building, reflect what the building is, why the people go inside. So the facade is not the element just for decoration. Facade is part of the identity of the building. And to be honest, ceramic, I love for ceramic a lot because it's a very resistant material, don't need maintenance forever, so for many, many years, and we built this building many, many years ago. This is another ceramic facade. This is Jiao Tong University in Shanghai. And this is a green energy laboratory where they realize some experimental for researcher. And I say, okay, what is the best is to cover completely the building with a skin that protect the building from the sun. Because when in the internal there is an aluminum facade, but aluminum absorb the sun and create problem of heating internally. So we don't want to use a lot of air conditioning because it's a green energy laboratory. So the idea was to protect the building with this facade in ceramic that creates shadow on the aluminum panel and reduce the temperature. So there is an artisan in Italy, I was there, that create this element in ceramic. We attach with a glue in the steel panel and we attach. So it's not easy, but this character is a Chinese character. And you have four characters. One represents wind, one represents fire, one represents air, one represents water, the four elements. And with this Chinese character, is in tiles like this, is an extrusion, and we glaze it also, is a porcelain glass. We introduce in the frame and we install. So after 20 years, it's perfect. Perfect. And I'm very happy to realize this. Originally, the building was like this. I don't design this. I arrived this when the building was just quite finished. And asked me, we don't love the building. We need to update with this new facade. Yes, it's okay, because the building in aluminum is not an energy laboratory. It's just a washing machine. So we decide to cladding, to cover like this, and to design this. And also for maintenance, you can walk here. Like you mentioned, you can walk inside, you can clean the facade. So it's exactly through what the speech before me give us the suggestion. We need to clean the facade, we need to maintain the facade, we need to have attention of this. And this is rules of architect together a good engineering. So this is another residential building. We designed different pattern, but was the same technology. This is another kind of work. This is fabric. Is a silicone and cotton. This is the Shanghai pavilion for the Expo of 2010. We won the competition for the pavilion, but the client told us, we need to disassemble the building when the Expo is finished. So 90% of the building need to be easily to reassembly and to disassembly. So we decide to use the textile material installed in a frame, in aluminum frame, and the facade looks like a painting. There is a famous artist in Italy that now passed away. It's called Castellani. Enrico Castellani is a great artist. And I work with a lot of artists also to design the facade together. And we designed this facade together. It's not bad. It's a textile, move a little bit, so we can work also with this element. But after 20 years, they decide, don't disassembly is existing. They don't disassembly and is the only one pavilion that resists there. Okay, other facade, this is in concrete. We don't have money here, this is a school. We don't have money for cladding, we don't have money for facade. It's governmentally very low budget. So what I can do, I built in concrete. Yeah, but this concrete is in curve, so it's a self-compacting concrete. It's a special concrete, very, very fluid. And we use also, in that case, to use pigment inside. There is a pigment that become brown, like the earth. And also this is facade. But we don't have money for facade. So structure and facade and material is the same. When you don't have budget enough, you need to think how you can use the structural part to be part of the facade, to be part of decoration, to be part of the building. But this is a school for disability people that live in hand-raised share. So the life of these children is connected to the wilds. Wilds is a what, I think? points, yeah. And we design a lot of circle inside, and the circle move, and when the sun go inside, you feel that they change the timing. So in the early morning, there is one design inside with a light. In the afternoon, there is another light. So that's it. And that's the circle. And this circle is just the projection of the solar, of the sun, and change. So and day by day, you understand how change the timing. So what I want to tell you, we need to work when you don't have money enough. We need to work with the sun, with the wind, with the structure, with the simple elements. So this is a simple, very simple school. This is another facade. I love to work with the material. This is a concrete for floor. So sometimes you know that when you design a piers in the for the yachting, the wood it's for maintenance a problem. So there is a company that realized this wood in concrete, so you can install in the piers and don't have any maintenance. So that's a good idea. And I tried to use this material because I want to cover the wood in the beginning, but the client told me, no, I don't want wood because there is a lot of maintenance. So I no problem for the maintenance because when the wood become old, it's beautiful. No, please. I want material that don't ask me anything. So I use this fake wood. It's fake wood, it's concrete. And we install in vertical way, and we try to change the orientation of the element and change the color because change the light. So again, you can work with the light, artificial, natural, sun, wind, and you can try to design the facade, but try to design your material. Also, this is not material for facade. For sure, you need to design how you can anchor, how you can install, how you can maintenance, how you can clean, blah, blah, blah. Okay, that's it. This is work that we need to do. But in the beginning, we need to have the idea, which is the identity of the building, which is the character of the building. How you can design this, how you can work through the sun with a natural element. So this is another building, very simple. Another government building, no budget. When you work for the private, you have money at your disposition. When you work for the government, especially in Italy, the first issue is we don't have money. We don't have budget. Okay, that's it. What we can do? We don't have budget for facade. But facade is important. So I was there. We can use only precast concrete because this is the cheapest material that you can find in the world, precast concrete. So I was in this company that realized the structure for the slab, for the pillar, for the column, for the beam. Say you work to realize concrete for beam, slab. Okay, can you realize some panel in precast concrete that cost, I don't know, unbelievable, 85 euro each square meter, nothing, no budget. And you say, okay, we can cover the facade of this building with this element. This is the cheapest that you can find in the world, is concrete. And we try to use a different pigment inside, color a little bit, and realize this is a simple hospital in Italy. But it's super cheap, absolutely not expensive, and we don't have enough money for this. This is Jersey building. This is Shanghai Tongji University. We won the competition for refurbish an old building in Soviet style. It was in concrete, and I told them what I can do. It's impossible to change anything. The structure is done. Just I tried to change some different shape of the windows, and we tried to consider the building, exactly I want this. You see this? You see this curtain here? Exactly this. I want to cover the building like this. How I can realize this? In fiber concrete, say, okay, we realize in fiber concrete we want this bronze effect, but what you see here, you see in this side is exactly the same. That's what the effect that we want to realize. And thanks to the fiber concrete technology, we can realize this easily. We design the pattern and in a different way that the wind move the building and realize. Okay, now, my first building, 30 years ago, 93, one of my first buildings. In Italy, nobody used curtain steel. Nobody used. Now everybody uses curtain steel. Everybody in the world. But that time, 30 years ago, that curtain steel it was used only for the structure, for the bridge. I say I want a material that don't request maintenance, material that become old. We don't have money also here to cladding in a very special way. So we realized this panel in curtain steel we attach, and in the night we have a light in the back, and with the hole go out. Where we take this idea? From a very famous artist, Lucio Fontana, one of the best artists of 20th century, that cut the painting, the canvas, and we work with this idea. I have no money, I have no budget, what I can do with the poor material and create something special. And we realize this building, we attach cover. But there is a lot of problem here. For example, we don't have enough surface to add the volume. And the municipality told me, you can realize your facade. Why? Because you don't have enough volume, you increase the volume. But I introduce here some wilds, and this facade is movable. If a movable in Italy for the law is not a building, so don't add volume. So okay, each column have a wilds here, it can move a little bit. If it move a little bit, it's not fixed building, it's not building, it's another issue. And we'll try to realize this. Okay, in metal, another facade, this is a stadium that we built this stadium in Udine. In Udine, in north of Italy, there is a company called Electrolux that produce oven for kitchen. And they are fantastic to work with stainless steel. So stainless steel is part of the identity, industrial culture of the place. So I say, I can use the technology that you're available to use in a very easy way. So I was in this company, Zanussi, and the supplier that works for them to produce cladding for the washing machine or oven, say, can you cladding for me these stainless steel pieces? Yes, can do it easily. Okay, and this is the reason why cost not so much, and we cladding all the facade of the stadium with this. But why we use the diamond? Because the stainless steel is expensive. We don't have enough money to pay. So, and if you want to have resistance to the ice that go from the sky, for example, sometimes we need to realize like this with diamond, instead to have a more capacity to resist of the wind, like in the car design. When you have element in the car design, you need to have this element that have a more stronger in the doors, for example. The line that you see in the car is not for design, to have a less steel and to be resistant. So we clad in this building and we realize the facade of the stadium. So last is the facade that is here in the Alban Tower where we go, is in Tirana. This material is a precast concrete with a Murano glass inside, polished. So we realize this precast panel, but I want a panel with a glass inside. So there is a company in Italy that realizes precast concrete, say, I never do this, not working for sure. Okay, try. Try to put this piece of glass, a circular glass inside, and we realize this precast concrete. But in the end, we finish in aluminum because we finish the money. So we start with the precast concrete, and step by step it becomes in aluminum. But when you say 100 meters, you don't see. So downstairs it's like this, and floor by floor becoming aluminum. That's not a bad result. So sometimes you need to resolve. When you touch in the first floor, second floor, third floor, you can touch this. It's beautiful. And step by step become aluminum. And the result is not bad. It's well, sometimes you need to work with this. This is the stadium. I go fast. It's aluminum facade. It's very famous. I don't tell anything. But again, we print in basso relieving the aluminum, the Albanian pattern dressing of the old. And so I think it covered the facade with 200,000 column that relies like this. So I go fast. But everybody knows this because it's in Albania. So this is an art gallery in my office. Also here, the facade is important. So, but I want to spend time because my time is finished. And I ask you, sorry, because I'm 2 minutes longer. That was my time. Thank you so much.
Thank you. Thank you, Marco. Thank you once again for showing us what creativity, when you don't have a lot of money, helps to design good buildings and iconic buildings. Now, on the topic of multi-parametric behavior of the facade against fire, I want to invite Mr. Angelos Zografos, Technical Sales Engineer at Elval Color, and also want to remind you that the Elval Color booth is outside on the hallway if you're interested in their materials. Thank you.
Thank you very much for the introduction. I have to say that I've been to several Zak conferences around the world. Following and watching Mr. Casamonti's presentation is one of the times that I say, yes, architecture is cool, facade engineering is cool. Very interesting. So, I will present some issues and how several parameters interact in fire behavior in facades. First, we will see some functions, the tests that are used, and the current challenges. If you see that I'm a little bit anxious, I'm going fast, is because the specifications of the project changed. The presentation was prepared for 20 minutes, and I have to do it in 10. I'm not going to hold you for all this time. But again, as Mr. Casamonti said, you have to squeeze it, you have to make what is possible. Why facade? This is something self-explanatory. We see new projects, even new visions, like here in Albania, in Tirana, where is the new vision of redesigning the city. The first thing that the investors or the people that take the decisions is the facade. They don't see the interior, they see what looks inside and what redefines the architecture of the city. Of course, the roles of the facades are several. Out of all of this, with most of them are functional, I would like to keep the identity, the symbol, because if something happens, something good, of course, everybody will remember it, like the stadium we saw earlier. But if something bad, again, everybody will remember it and it will degrade the value of the project. Why fire protection? When we discussed about the topic of this presentation, the fire here in Tirana did not happen yet. We were saying that perhaps it's not something that should be current, should be presented, because everybody is presenting this again and again, but we understand that it remains always current. It has to do with protection of human lives, the protection of the value of the projects, the damage of the environment, because I don't know if you have seen any of these kind of sites. I've personally been to sites like this. It's unbearable. You cannot, some cases you cannot even live there anymore. And of course, the management cost for the government and the owners. Most of the discussion is done about the things that we see, typically for the cladding materials. However, we understand that it's not always the case. It's not always the cladding material. We could use totally non-flammable materials and still have failures, because it has to do with combination of products. Again, non-flammable materials, titanium, zinc. If we look closer at the whole assembly, we understand there are many things. For example, the air gap, which is very important. We have seen it also in fires in France that might have affected the performance. The anchoring or special architectural elements, that the more complex the architectural approach becomes, the more challenges we face. Why now? Apart from the incidents that we have also intense activity. So many challenges, things have to be realized very fast. We need to have, in some cases, value engineering, so there might be some compromises, delays, and keep in mind the supply chain disruption, because, for example, we have seen it with the coronavirus situation. Some materials could not be procured. We now face similar challenges. So compromises and a lot of pressure. By the way, to keep also the production and sampling, certifications. The more information we give, the more documentation we need, we add to the project, the more difficult it becomes for the engineers to evaluate and for the regulators to oversee. AI is not going to help us with that, because the AI cannot go to the factory and see what is actually happening. Whenever we have new developments, new types of projects, for example, the challenges with high-rise projects, we have seen it in Cyprus, where the regulation was not so well prepared for complex things, or in Greece recently, where we changed the regulation after almost 30 years. People might not know the importance, even if they see the incidents in the news. They don't know how to properly apply it, and of course there is the ignorance of the system function. It's not only one material. Why el Valcolor? Because we export in so many countries that we have to go under many regulations, under many testing, under many certifications systematically to provide material for the building envelope, like roofing, and for the facade specifically, aluminum composite panels and solid aluminum. We can discuss about this later outside if you want. Of course, we participate in all the regulatory bodies like the Aluminium Association. And of course, we are also present in projects here in Tirana with very custom finishes. Like the Corten, we say there are alternatives to that in order to reduce cost and to improve manufacturability. Regarding the behavior, the first idea is to understand that we don't need for the facade the resistance to fire, but we need to control the fire propagation. Because there are different ways that the fire will propagate depending on where the fire is situated, if the material will allow the movement inside the cell, or it will have to bypass and leapfrog and go to the other floors. This has to do with the assembly and the interaction of the materials and the geometries. The first thing to do was to test for surface propagation. So take in consideration how the fire spread will work on the surface. According to BS 476, part 7, this was something that gave different propagation, but actually reality showed us that this was not reliable, because there are cases where you should apply a different methodology, the EN 13501-1, more complex classification. They take consideration also the smoke. This is very important because smoke production is what actually kills you. First you suffocate, then you get burned. In the Euro classification, for some regulations, they also use this kind of classification in combination what is the distance from the edges of the site, what is the type of the project, if it is a hospital, for example, or a kindergarten. The cladding materials have different classifications, starting from stone, which is non-combustible, and reaching down to fully combustible, like PE aluminum composite panels. The two comparisons show that it is way better to work with classification according to fire reaction. More complicated, it takes consideration also the burning particles, the heat release, and of course it is superior to just checking the surface spread. However, the way this kind of performance it is tested as a single material is not enough again. We understand that this testing was prepared for a different positioning of the fire. It doesn't take in consideration the bigger scale, how the materials react to each other. And we know that there are more complicated issues. That's why several countries around the world have designed and performed and incorporated into the regulations more complex testing, a system test, a system evaluation, where they evaluate with different criteria how the fire will function regarding propagation to other floors. The United Kingdom has this kind of testing, Malaysia a little bit more complicated, Australia the same, different geometries as we see here. It's not only a flat surface, different fuels that are used. This has to do with how the temperatures are distributed across the facade. Openings here in France. Here, with this kind of testing, they evaluate the propagation from floor to floor. However, while this is the best solution so far for evaluating the fire performance, still we don't have a unified European regulation. It is under evaluation, but is not definite yet. If we see each of the single parts that how they affect, it is already tested that, of course, the insulation also takes a very important role with different assemblies that were tested after Grenfell. Even cases where we have totally non-combustible material as a cladding material, there were failures. The fire barrier is very important, how you control the fire inside the two layers. Detailing, it affects how the fire will move. Detailing, again, because you might design certain things and it will completely create different openings if it is not properly either designed or applied. Prefabrication, which increases the quality of the project. Special geometries that are not taken into consideration in the tests. New materials where we don't know the new forms, how they fail, or we don't have the proper training for application. So there might be mistakes incorporated in the application. For example, non-combustible materials that can, due to explosive breakage during fire, might create openings that will lead to more oxygen in the fire. New applications like photovoltaics, where we know from the United States especially that can lead to many problems because of the electrical parts. Several architectural trends that change completely how the fire will propagate on the surface, like the perforation. Rehabilitation is a very important thing, how you incorporate and combine different materials, existing structures, and all the new regulations without jeopardizing the performance. Apologies for the low quality because this is it was very high, couldn't upgrade it. This is after a windstorm. Openings that were created in the facade, special care in order to see what happened, why it failed, and how to fix it very fast because you create openings in the facades that might lead either to more problems, but even expose materials that shouldn't be there. The sustainability, where we say that we want more years for the material to withstand the environmental conditions. However, in order to do this, for example, in aluminum composite parts, in coated aluminum, we need more layers of coating, which is thicker, which provides more energy and attributes to stronger fire. Some companies have certifications. You need to test this. You need to evaluate it that the class of the fire according to 13501 will not change. Not all companies have taken this into consideration. So the parameters could be several regarding materials, regarding material aging and modifications, but of course we don't have to forget environmental conditions, types of fuel, even the terrain shape. The engineers from Arup will verify that even the topographical conditions will change how the wind moves and how the speeds of the wind will affect the fire. So we see that there are several parts that affect the whole process. The supply chain has many people inside. We don't forget the investor says, I don't have money. The special consultants, we want to squeeze the cost. The material resellers might say, we don't care about what is said in the regulation, we can push for other materials. The government that has to be updated, has to incorporate the new things, and the fire service that has to live with our selections, with our choices. The users that most of the time have no idea what they are living in. And they have to push for this. I will be done in half a minute. The material producers that have to help in this process to add value. And of course, several social influence groups that must push for better facades. So it's not one thing, it's a complex system. We need to understand it in order to provide something better. We push for, we need better education, better training, fire certification, to understand who is responsible for what, to take responsibility in the design and the material selection, in order to have facades that will be remembered in the future for good reasons. Thank you for your time and your patience, and enjoy the rest of the conference.
Thank you, Mr. Zografos. And now on the topic of interplayers, application and case studies shaping the future of facade, we invite Mr. Sandro Casaccio, Senior Manager on High Performance Projects at Curare Europe. Welcome.
Thanks a lot, Jan. Good morning, everybody. So today I'm going to talk about our portfolio, then we go through some case studies and a little topic about counterfeited products. So before starting talking about products, I will introduce a little bit my company. I'm working for Kuraray, who is a Japanese global company with headquarters in Tokyo. And specifically regarding my business, I'm from Advanced Interlayer Solution, IS. We are also global. We are in the main 3 regions of the world, so America, EMEA, and Asia. We have 6 facilities. 3 out of 6 are in Europe, 2 in Germany, 1 in Czech Republic. We have 2 labs and different sales offices in the main countries, plus some technical support to our customer. So now let's go into our portfolio. You can see from this slide, so the applications are different. We have a product for safety, so we have 2 product, clear and ultra clear. We are in decorative, so we're talking about color stints, solid color like black and white. Acoustics, we have 2 specific products, 1 monolayer, 1 multi-layer. Structure and security, the main, let's say, the most famous product is Sentry Glass, that has been also mentioned in a couple of presentations ago. Sentry Glass Extra, which is a new product, and Translution White, and so on. We have also some specialized products. We can talk a little bit about this later on. We are also, of course, in automotive, which is the other part of this business. Last but not least, we have recycled material. We have a couple of products, and those are really stick on our mission regarding sustainability. So more than 1,000 words, I will show you a very brief video in which you can see many applications. This is just a rendering regarding a mixed-use building in order to explain, you know, for the same building, maybe you need a different kind of interlayers for different, let's say, performance applications. For instance, if we are talking about the ground floor, in this case, we're talking about retail, luxury retail, For sure, we need some acoustic material, just considering this being in a city, so a very crowded place. On top, if we have a luxury stuff inside, we need maybe an anti-intrusion. So this means another products, transparencies, maybe bigger glass with high structurality and with more mechanical properties. If we move on top, so we talk about, let's say, first and second floor, we have a library here. In this case, again, we need acoustics for keep quiet the inside area. But another important product that maybe can be used here in this case is a special product to just prevent that we have a degradation, discoloration of the books. So every interlayers has what we call UV fillers, so UV stopping, but there are also some special product that can work even better. So in that case. If we move on let's say from 3 to the 6th floor, we are talking about residential area. Again, in this case, we are talking about maybe we need aesthetics, we need much more, let's say, visibility, so bigger building, glassing, so we can use product very, let's say, with very high structurality like century glass, for instance. And also we need also some acoustic. Let's go on the last, on the top floor. In this case, we have a terrace with a greenhouse. For instance, in this case, UV is not enemy because plants, they need UV, and we have also a special product here without any UV stopping on filters, in order to feed the plants. In the meantime, you have to consider maybe this is a workable area. So we were talking about, Arup was talking about assets and maintenance. So this is something that has to be taken in consideration. Last but not least, you have also a lot of balconies, balustrades. Those are, open edges, no profiles. And even in this case, you need a special product in order to avoid any moisture, humidity inside. So delamination and probably bubbles and probably delamination. So now talk about case study. We start with the first one. This is Montparnasse Tower in Paris. This tower was built at the beginning between 1969 and 1972. Just to give you an idea about the dimension, we are talking about length and width 60 meters by 40 more or less, and the building tall is 210 meters. So it's quite a big building. Here has been done a value engineering exercise by TESS, and there's been, has been considered, the facades, how much was the content of CO2 carbon, and 30% is just into the facades. Then has been taken in consideration the biggest facades, the one with these 27,000 square meters, the one in pink. And to go more into details, has been taken just the outer pane, which is, we contribute in terms in negative way of 20% of the carbon. So what has been done? Also some load simulation, so with the wind function, so negative pressure and positive pressure. And has been put in comparison two different kind of laminate safety glass. So in one has been used PVB and the other one has been used century glass. So which was the outcome? The outcome was very clear. So if you go with PVB, you need much more glass. And this is the one on red on the left side, you can see. And so in the worst case, we are talking about the thicker 1815 for PVB, and the worst case for century glass is 1512. So which means at the end, if you go on, what happened? Okay. So at the end, what you can achieve just changing the interlayer, 20% of carbon content inside of the facade, so which is a very good results. This is another case study, is another project. This is in New York, Fifth Avenue, Apple Store. I guess most of you know this building. And originally, this was done with PVB interlayers. To do that, in order to have this kind of structurality, needed 90 paints, so really a huge amount of glazing. and has been remade and with century glass year later, and this was the outcome. So from 90 panes in PVB has been reduced just to 15 panes. On top, you have to consider that you reduce glass thickness because it's a more structural material. In terms of aesthetics, it's much better, more visibility and so on. Here we have another project. This is Steve Jobs Theater. This was necessary, you know, just to support this big carbon fiber, which is a diameter of 60 meters. And this has been done with 44 by 7 tools glass with century glass, just standing 80 tons, you know, of this big roof. This has been over-engineering in order to, let's say, to withstand, you know, an earthquake, magnitude of 8 Richter scale. And there's been also considering in case of every 2 glass, one of these breaks, there is possibility to keeping, you know, on top, you know, the roof does not collapse. Just a few words about counterfeited products, which is the difference between century glass and SGP. This is something very important. First of all, a century glass is a product that has been invented by DuPont more than 25 years ago. And for many years on the market, the industry was calling the products SGP. So then 15 years ago, DuPont decided to reduce, to drop, you know, this plus, and the product became century glass of SGP. So what happened just not long ago, there were, oh, by the way, we are as Kurai, we are the only global company with the license patent to use this product with the raw material from DuPont Dow. We have the license, you know, about this kind of product. So I was saying that not long ago, it's been introduced another product on the market, and it's called SGP. Clearly, this has been done on purpose to confuse the people. It's a different product in a sense they are using, you know, different kind of resins, and in terms of performance, they are really very, very low. So, in case you really need century glass, when you specify, please use century glass or SG by Kurai, because if you put century glass SGP, you can open the door to everything, and then you can have a problem. We have a history. We have no time now, but we can discuss later on. We have a booth outside. There were projects where there were a disaster. This is just one of them. This is in Australia. This has been done with what we call fake century glass, and there was a lot of delamination. It was really a disaster. This is what happened in terms of post-breakage behavior. If you look, you know, on your left side, you have, you know, this fake century glass, and this the post-breakage behavior when you use century glass, the real one. So this guy breaks the glass, nothing happened, you know, nobody falling down into the field. This last slide, really running out of timing. So it's just a base specification, it's just a summary. We have a lot of documentation. You can get a lot of stuff. So you can go into our website, www.kurai.com. So it's very easy. Anyhow, we can be easily contactable. So again, if you want to talk about this stuff or something more, we have a lot to discuss. We are outside, myself and my colleagues. So that's it from my side. Thanks a lot and enjoy the rest of the day.
Thank you, Mr. Casaccio. And now for the last discussion presentation of this session, I want to invite Mr. Beat Huesler, Manager Director of Oppenheim Architecture, to discuss and present on several of his and his studio projects in Tirana, and the topic of facades, a civic identity, shaping contemporary Tirana.
Thank you.
You're welcome.
It says already, please finish quickly. That's not for me. But okay. Thank you for invitation, Zak, and then we're going to go through a series of projects rather quick. Showing us and showing to you, I mean, what facade means for us. It's more than just decoration. It's more than material. It's actually very, very human. And shortly about Oppenheim architecture, we have offices, Miami, Aspen, and in Europe, in Basel, and in Tirana since 3 years, and I guess that's what mostly I'm here for. We have a large group of international talents, some of them Albanians here, and some of them also here in the room, that work on all of these projects around the world. And lately, we have actually some projects on a boat and on the metaverse. It should move now. But what really drives us as architecture is the notion that today we are the most connected people and humans ever, but we are the most disconnected ever. So how does architecture, and in this case facade, connects us with its environment, connects us again with the context and the surroundings? And that's really something that drives our architecture and drives also the decision what materials we are using. And some examples around the world of projects before we're coming to Albania. This is for a water treatment center outside of Basel, and we were kind of trying to find a material that kind of does connect the project to its surroundings. That's a kind of unfortunate image of me going into the forest on the site, trying to find the clay that then does help to shape the building, that the building itself kind of really melts with its context, and the facade kind of dissolves. So it becomes these monolithic, these objects inside the forest. And the material used here, which is shotcrete, this is actually what I've been told after the fact. This is the world's largest shotcrete facade that we build up. Shotcrete is a technology you usually have for tunnels and infrastructure. We use it here for facade. So the water does run off the edge of the building and kind of does change the texture and the patina of the building. It becomes kind of a really nice moment inside the forest when you detect that huge infrastructure building in the forest. It helps us shape it. It helps us creating texture and tactility and very interesting moments in the building. And the same time, this is just the inside, that the facade material actually also opens up to the inside. This is kind of a viewing platform. You see the technical aspects of the water treatment on the right side. There's a gap on the roof where the water is collecting. So in a rainy day, you're actually looking at all of the infrastructure through a waterfall screen, but you start to smell the facade, which is a really nice moment. At the same time, we're having a project in Jordan at the Red Sea, and that's the site that we found this man-made and natural dunes. And we were thinking about how we can create this golf clubhouse on this site, and learning from these sand dunes, and created kind of this carpet of material that laid over the program and over the project itself. We brought, because we had some experience now with shotcrete, we brought some Swiss shotcrete specialists to Jordan, training some local Bedouins, and it's easy to recognize the Swiss engineers, the one in orange, and compared to the Bedouins. They were teaching this very primitive kind of way of building to the Bedouins, and they built the structures then by themselves, creating these incredible forms and shapes. And the kind of the facade dissolves. It's not a decorative element, it becomes the structure itself, as we heard from Marco before. In this case, very incredibly done with the surface. This is the context. There are millions of minerals to be found in these mountains. And we have this local Bedouin artist that collected all these minerals. And he applied all these minerals to the facade. This is him actually creating the facade. This is gold out of the mountains, and turning these facades into these incredible textures and materiality, and that blends so well with its context. And it changes season by season, and it gets older as the water runs around. So this is a golf a clubhouse that becomes kind of that silent monumental center of a whole development at the Red Sea. So for us, a facade and the material is not just decoration. We want to touch it, we want to feel it, we want to smell it. And there was a perfect program that came to us in Saudi Arabia with a client that said, we want to do a hospitality project that's never been done before in the desert in order that you appreciate the desert in a different way going there. And we've been told to find a site, find a mountain. We selected this mountain and turned this into this resort inside the mountain, inside the rock. It's called a desert rock. With geologists, we went into the site trying to find the specifics of the location, the softer stone from the hard stone, to turn this into spaces and rooms and different moment within the project. So this is actually a project where facade completely dissolves, so maybe not the main topic of this show, because there is, in many cases, no facade. We really use the nature and use the existing as the facade and for the experiences. This hotel opened like a year ago. It's already now sold out for the next 6 to 9 months, because it just creates a very different experience in using the local its context as its facade and its fully immersive experience. Obviously, a lot of influencers going there, so we get all these free materials from these influencers, which is very, very great to do. At the same time, with the same client, we were approached, how about a hospitality project on the water in these beautiful coral reefs, also at the Red Sea, and try to create like an experience that never been done before. So we created these reflective cubes done. They were actually built by a ship wharf and in Northern Europe, and brought all fixed together on site, hovering above this protected area, reflecting the land, the context, the light in a beautiful way to really experience its site in a different way. Same influencer, going from one hotel to the other. I could watch forever while you shine on everyone. Wanna go hard, wanna have fun, wanna be happy, could you show me how to look so pretty, pretty like the sun. I could watch forever while you shine on everyone. Wanna go hard, wanna have fun, wanna be happy, could you show me how to look so pretty, pretty like the sun. So what we appreciate and like the most is when the architecture, the facade blends really with its context, and when they get better together. So these moments when you can appreciate and reconnect, as I said at the beginning, that we are really disconnected. You put your phone aside when you're there because you just appreciate what you have in a different way. Now moving to Albania, that's why we're also here. How do you do that in an urban setting? How do you do that in a setting with a client? We talked about it many times, limited funds. This is part of the whole master plan of the new boulevard. We got the privilege of have the site at the entry of the park. And there's so much learning of Albania in its history, how the facade, and this initiative by the former mayor and now prime minister of colorizing the facades and reconnecting to the people and showing them change. And with these murals, there's a lot of history about that and how that can influence it. Also the history of a very, very active ground floor with all the cafes. So at this corner side, we decided not just build this GFA as requested by the client like that. We start to massage the site, cut openings in to reconnect to the park, get new view vistas, connecting to the context of the master plan roofline, creating then an iconic tower and massaging it, and creating an open corner for cafes and its inviting moments. And the facade itself, as this is one of the very early projects we had, and there is also a big discussion about money and funds. We went very kind of try to go primitive into the structure and profit from the Mediterranean light. That light is so strong that helps us to make a very, very strong message with little means. But we have like this urban monument, as we call it. We start to create this or add this porosity to it and articulation without losing the larger idea of this kind of carved rock, but try to be also kind of engineered that we have a repetitive moment without becoming kind of repetitive. And the facade, as Mark also said, became structural. You have a structural facade, the client cannot take anything away through the value engineering. So these are the first steps. Like this is 5-6 years old, this project is now under construction. Simple ways of dealing with the situation. But you see how the project tries to be like a good neighbor of lining up with the master plan and then becoming kind of an iconic corner piece and an important element at the new boulevard. The corner is then lifted up on a very tight area. We wanted to create public space, and the public space would be then that coffee corner at the end that at night becomes a very interesting kind of gateway to the new boulevard, and also visible to the inside of the coffee. There is then, of course, the backside, which is the park, which has another important public space part of the program. But the facade is very simple. And we had for last year's Better Heart Festival a big mock-up, a one-to-one mock-up. People really like the texture of it in a simple way. It's done, but it has a lot of depth and has a lot of tactility that people want to touch the facade. So I'm happy that this is going through the process right now. Another project is another tower in Tirana. And like every new architect coming to Albania, first you get caught by all the Albanian motifs and graphics. They're so strong. I know for many of the local architects, it's kind of, okay, another international office that starts to deal with the motifs. But then 7 years ago, when we started to work on this project, we really tried to see what's the potential of the graphic, not just as a decorative element, but becoming also structural and much more a voice of Albania in the facade, and how can it help us to reconnect in a better way. So same idea, structural facade, but at the same time, and more supposedly, how does it frame the perspective to the outside? How do these structural elements reconnect you to the mountains in a different way to make your presence stronger in this area? So these openings also help us to rescale the project. You can't really read the number of floors. We kind of have larger and smaller openings and a very interesting scaling of it. The facade patterns change direction. So there's a very interesting light change of it, a very, very simple and low cost element, an idea to create depth to it and interesting moments throughout the facade. There's also the idea that there's always a courtyard, there's always green space for the public, there's always space for a cafe. So it's not just an object, it's also an inviting building for its larger context. And one of the last projects, is our College of Europe. It's a university building for Europe. There's one in Poland, there's one in Belgium, and the third one is going to be in Tirana. And the client was like, yes, build us a school. I'm like, no, you can't just build a school in Albania. There's so much history, and the building needs to address this, and the students that come from all around the world have to learn about Albania through the building. This is on the site, and a very, very important building, how the facade can become public. I mean, it's kind of inhabited by the people in this facade, and how can we learn of that in this project? There are three large components: public, students, and delegates that were asked for to have in a project, and we created a fourth one, which is the Agora, the auditorium space. And we kind of got the program separated to each other. Each one has its own building, and the building is lifted up from the ground. So there's a very public loggia. We call it a public foyer, and we added like the art squad, the student park on top of it, and it becomes very, very transparent in the ground floor. Lifted this up and created then kind of a deep facade, again learning from history of all the students behind on these balconies, and actually the loggia we framed with the rhythm of the columns that go with the hymn of Europe, the joy of OODA. So if you would run fast enough along the facade and have your finger, then you have kind of the music of the hymn of joy of OODA in the facade. But that's kind of little playful reconnection of how the facade in Europe and Albania. This is kind of the overview site. Again, the history of the murals and colors in the city, and how can we bring this into a contemporary project. And so bringing the volume in three, or breaking it up in three different volumes, also helps us to find the right scale in the context. You see how colorful the city is, actually, and how this can kind of how we integrate our colors really well within that large context, and with the large murals, with the large skylights. But most importantly, the facade becomes alive. We want to have all the students to go out to the loggia and to reconnect to the people, and the people from the outside see all the students. So for a school building, that's rather not normal to have loggias, but here it's also a cheap and simple way to protect the glass from the sun. From the hot Mediterranean sun, and it creates depth, it gets shadow at different moments during the day, as said before. That's the big auditorium that becomes an object in itself, and is kind of symbolic of the entire project. There's a big public stair bringing you to the park, to the university park above. There's a large park on the site, that is also public. And you see the big stair bringing you up to the upper park. So it's the building itself is different what the client asked us to have from at the beginning, saying, give us like a school that has a key and then that's it. And we wanted to connect it with the people. So the auditorium becomes also a public theater for the people to go there and reconnecting to the school. That brings me to the last project. It's just around the corner, the Beza Museum. It's museum. It was a competition, and it's a very special museum for Albania. It's a museum about nothing to show. It's about the feeling. The Beza is the feeling of. It's difficult to explain that to a room of Albanians because you all know what it is. But it's about protection. It's about hospitality. It's about that the guest is above the family. And how do you show this in a museum? There's no artifacts to show. So it's all about feeling. And we kind of call this in our office, form follows feeling. And how can we represent that? So we have the old Toptani house, heritage building being renovated. And we decided to put the building, the museum, the new part on the ground, to protect the outside space and not be in the way of the historical building, and use these huge symbols of Beza, the four elements of Beza, as light wells and symbolic elements that travel around Albania. So the new museum will be on the ground in this beautiful entry park, and we have these 4 pillars of Beza that bring in different ways light down to the museum and create stories. And so again, they're not really artifacts, they're storytellings of how Beza protected so many Jews through the World War, and how these stories are being told in these spaces. So these light wells are creating very atmospheric moments within the museum, become kind of the iconic moments around. So the old house will be, of course, very carefully renovated. That was the old OODA. There's a new OODA. OODA is the living room for the guests, which actually is more important than the living room for your family. And this is all celebrating these moments of Albanian history that we're very proud of as an office, that to be part of and won this project, which we start construction actually this year. But the facade, again, it's almost primitive, you may say, but you want to touch it, you want to feel it, and it's very, very Albanian, if you ask us. But it's going to be an incredible museum that is very, very, touches your soul when you're in there. And the last one, just off the board, is a big master plan on the beach in Vlora, which we're working on, where we took the principles of old Vlora village, which is a very colorful little center, and All the colors you see here, you find in the centers. All the window openings you find here, you find in the center. We we kind of translated them in a contemporary language, but created a village which is very organic and a village is very friendly and very Mediterranean, that is connecting you with the place and with its contact at the beach. So this is not going to be a luxury hospitality project. This is for the people of Laura, and they have a new part of the city which is directly at the water. I was asked for the London Times, like, is this going to be a luxury and so forth? And our response was more like, if luxury is that you can send your kid barefoot to get some bread in the morning at the beach, that is then a luxury resort for us. And we're very much looking forward to kicking this project off too. Facade-wise, very simple moves, very protected from the strong sun. I'm giving a lot of depth, and hopefully we can connect with these projects, us to its context and surroundings. So thank you very much.
Thank you so much, Bat. And this is the end of the session. Actually, I would like to invite all the speakers and the panel members for a memento session at that part of the stage. Thank you. Yeah, and we have a 30-minute break for coffee and talks. 20 minutes.
Right. I think we'll start this session. Those who are outside will join us a little later. Our host, Jona, was called by the municipality, so she has to go and attend a meeting. So I'll just step in for her. Just a question for the audience. How many of you have ever visited an Apple store ever in your life, in any part of the world? I see a few hands there. Sorry, one sec. Right. So, okay. Okay, a few people are there. Well, if you visited an Apple store, the most striking part about the Apple store is the glass. I think Apple as a client has been able to push the boundaries of glass. They've been pushing for a large jumbo glass from the beginning, which meant that a complete new sector was advanced, which was basically the architectural glass sector, which moved from 6 meter to 9 meter to 12 meter. And now in China, you can produce 23 meter single piece glass. So the firm behind engineering these glass structures for Apple are the ones who are going to be presenting next. So we have Chiara and Michele from Eckersley or Galán, the firm behind these structures, talking about engineering transparency and facade and complex facade engineering. They are from the Italian office of Eckersley or Galán, and they'll be talking to you about the work they've done and how structural glass and glass as a material has evolved, and what are the current trends and challenges in the world of architectural glass engineering. So let's welcome both of them on stage, please.
Hello, everybody, and thank you, Ahmed, for the introduction, and thanks to Zak for inviting us. Yes, so as mentioned by Ahmed, today I'm here. I'm Chiara Tosi, and I'm here with my colleague Michele Andaloro, and we are both associates of the Milan office of Eckersley or Galán. And yeah, today we will talk about the journey from design vision to building performance from the facade engineer perspective. Who we are? We are a global facade and structural engineering practice who is passionate about designing great buildings and enabling a sustainable built environment. The company was founded more than 20 years ago in London, and London is still our headquarters. But now, as you can see from the map, we have 11 offices spread all around the world. And in the last 20 years, we have been working on more than 2,500 projects. And our team now is composed by 150 people, more or less. As also had mentioned, our history is strictly linked to the history of glass design and glass design evolution. And in particular, is linked to our relationship with Apple and with the Apple vision of wanting to use innovative materials and innovation also on the design of their store, of their shops. And thanks to Apple's support, we managed to push the boundary of glass design throughout all these years. And we like to sort of explain our history with this example, which is essentially a stair connection. So glass design and glass transparency is all about connection and about minimizing connection. So on the left, you can see essentially one of the first project and one of the first connection we developed of a glass to glass connection, which for 2004 was already quite a good achievement and allowed to have a nice glass connection without having any framing. But then thanks to our evolvement on our engineering capability, but also industry evolvement and industry growth, we managed to develop an even more transparent connection with the fixings integrated into the laminations, as shown in the second image. And finally, the last image shows one of the latest projects where actually the connection is even more transparent, is even more hidden into the project, into the design. And yeah, this is the results. And another example is Apple Fifth Avenue, which was also presented in one of the earliest presentations. And yeah, this is the first design in 2006, which was quite interesting at that time because it essentially shows structural glass and structural glass connection with glass fins. However, there were some size limitations in terms of production of glass panels. But then, as you can see, the second design of this project managed to reduce the number of panels. And this is how. This is thanks to, of course, development of engineering knowledge and engineering capabilities. But in particular, thanks to the collaboration with the industry and the pushing of also fabricating larger panels, and also developing the design through research and development and testing of components. So all of the design was obviously documented and proven by testing. And yeah, this is essentially the results, but we would like to show you also a further project about the glass and about pushing boundaries of glass. This is the Steve Jobs Theater. And as you can see, here is another step, another level. Here we have a completely structurally glazed facade, a structurally glazed wall, which support a carbon fiber roof. So another steps towards the transparency, thanks again to the evolution of engineering, but especially fabrication and research and development. And then, of course, the glass project needs to take into consideration the environment where they are located. For example, this is Apple Mariana Bay Sands. The vision here of the architect was to have a completely circular facade, a sphere. However, we are in a very aggressive environment in terms of solar radiation and humidity. Therefore, we couldn't only use glass, but we had to combine glass with an opaque material. So we managed to develop this design, which anyway allows the architectural intent and some sort of transparency, but combining also the use of opaque material. And then finally, this is an important project for us because Apple Piazza Liberty in Milan, because it actually represents the start of our journey in Italy as a practice, essentially. And as you can see, there is a very large atrium with large structural glass panels, which is also another steps towards the transparency that we want to aim to. Obviously, buildings are not only about glass, so we deal with several materials, and we also deal with several scales of projects. Here you can see some sort of smaller project in terms of sizings, But also we work on a medium sort of size project, office buildings, maybe more regular facades sometimes. And also, the facade engineer has also to deal with tall buildings, so skyscrapers, but also airports and big developments of buildings. So a wide variety of changing and of design. And this links to the Albanian market. And
yeah, thank you. So what we've seen in this recent year here in Albania, we've seen it last year at the Venice Biennale. It's really a change and a push for contemporary architecture, where international design practice are really building a new history and a new identity for the country. And of course, in this scenario, the face of this change are the facade of the building. So of course, for us, it's of great interest to see what can be done in the country. And we think of our role as a facade engineer really as a bridge between many parts that have different ambition and different parameters. So we really want to be a bridge between the industry. So we operate with facade contractor, with industry leader for constructability and assembly related issue, but also with academia. So to push the boundaries of material research and material possibility, and also with the close collaboration with the architect that are really shaping the identity of the building and therefore the identity of the country and the city. And what we want to do is really a synthesis of all this input from many different players to make sure that the client and the developer really get a project that it's innovative, it's of technical rigor, and also has an inherent value in the material, the performance, and the system that are chosen for a specific project. So really our role is at the center to mediate between these different aspirations and these different parameter, and we see really our role as connecting all of these dots together to see for each specific project what is the most appropriate balance between all of these, to optimize different parameters that sometimes are diverging, and really find the project-specific synthesis for all of these aspects that really leads to the quality and then to the durability and to the value of a project. So today we wanted to show you a couple of examples from all over the world where we can see really this in action, where different parameters are coming together to define the design of a facade and then the design of a building. This one, for example, is Tu Taikoo Place in Hong Kong, where we worked with MBBJ on the facade engineering of this project. And it's made, let's say, of two different projects. There is the main tower, which is, a structurally glazed facade with curved glass, fully unitized, and then the bottom facade, the facade at the lobby, which is a structural glass facade with very tall glazing. So here we have a project at the lobby with 14-meter tall glass, completely self-supported without a structure, that it's really about detailing almost at an industrial design level, where really the engineering of glass is pushed to the boundaries. And then we have a project for the tower that it's a unitized system, and here really it's about efficiency and being cost sensible also for the client. So here it's about the optimization, following industry constraint and manufacturing constraint to make sure that the production is efficient as possible, even with variation throughout the project. So it's about mass customization and efficiency. And another example with different drivers, it's Albert Street in Brisbane with Henning Larsen. And for example, this project was really driven by sustainability-related concerns. So here, the push for the architect was really to mitigate the climate forcing in this specific concept and achieve a project-specific balance, as I was saying, between daylight harvesting and then radiation. So together with the architect, we started from the very concept, developing a facade that can mediate between harvesting and maximizing the natural daylight on the inside of the building, but also controlling the amount of energy that the facade receives to see what the best balance, depending on the orientation, the shape, and the geometry of the project was.
So a similar process, a similar approach to performance was considered for this project, but here in a completely different context. We are in Athens. This is a building close to the Piraeus port called Piraeus Tower. And we work at the beginning of the project with the architect Pila in the competition stage. So we started from this. This was an existing building built in 1975, which was completely not used. So only the three first floor were in use, and the rest of the building has never been used. So a building that was not fit for purpose, a facade which was not fit for purpose. So essentially, the architect wanted to give a different vision, a different design to this building, and give a character to the facade, and in particular, giving a kinetic, a movement aspiration to this facade. And how we did it, and actually aspiration of movement, but keeping the existing primary structure. And how did we help with this? So we started with some solar radiation studies, solar shading optimization, initially considering the whole building, and then analyzing some specific base of the facade to optimize the shape, the depth, and the orientation of those fins. And essentially, we advise the architect, we define the correct orientation of the fins throughout the height of the building, which allow us to reduce solar radiation, but also to reduce radiating cooling for the building. So that was a good achievement, because not only the architectural intent was met, but also the performance were achieved and improved. And we, in parallel, we also started developing some sketches to understand essentially how this facade could work. We started from hand sketches at the competition stage throughout the whole design, and these are a few images of our tender sketch and our tender cut drawings. And in understanding the construction method was actually very important and very interesting for this project, which is located in a seismic zone. So we decided to go for a unitized curtain wall, which was actually not very common in Greece at that time, and not only for a speed of installation point of view, but also because through the joint connection, it was the system that was allowing the maximum accommodation of seismic movement in this area. And yeah, this is a final image of the constructed building, and as you can see, this sort of vision that the architect have of having this moving facade, this kinetic facade, is even more evident thanks to the LED integrated into the design of our facade. So we talk about glass, but actually buildings are obviously not only about glass. So we would like to talk about a few examples regarding opaque facade. This is a development in London, Norton Folgate, and in particular, this is a building we designed together with HAMM. A big development in an interesting context, because there are several types of buildings, so existing building in which we wanted to retain the primary structure, combined with new buildings. And in an interesting context as well, because it's in the center of London, so there are some constructability issues to be taken into account. And in this case, we have been called directly by the main contractor, actually, because the original design was for a traditional facade construction, so end-laid bricks, terracotta ventilated facade, and glazing window installed on site. However, as I say, there were site construction constraints in terms of space, but also a requirement to reduce as much as possible the construction time, which was a requirement for this contractor. So what we did, we started doing some sort of due diligence that we typically do during the project, and we thought about different system of prefabricating the facade. We started from a more traditional, I would say, precast facade solution. However, precast is quite heavy, and in this case, we had to retain the structure, so it was not really suitable for this application. So then thanks to the collaboration again with the industry and with the manufacturer, we developed another solution by using UHPC, so ultra high performance concrete. And this slide explains how the system process, the fabrication process works. So in the factory, the UHPC is cast through a mold, and it's actually already cast with the ceramic tile on it, and also the bricks. So we have a brick face UHPC, but always in the factory we pre-assemble the glass, so the glazed facades, which by building these 8.5 by 4.3 panels, and then there was this third phase of installation of those panels, and finally the internal finishing was installed. So this process allowed to achieve the vision, the requirement of the contractor of reducing as much as possible the program. But also the client was happy because it's true that it required a little bit of more cost increase in terms of material cost. However, there was a saving in terms of time, of construction times, and they could rent the building much earlier than what couldn't happen by using a more traditional facade system. And yeah, we went to see visual mock-ups, factory inspection, and as you can see also there are a few pictures of installation of the facade. And this is the final facade installed. And this process of prefabrication, of course, allows us to control the detail, the interfaces, also as discussed in the previous presentation, and keeping control of quality of material and durability. This example is, again, an example of how we dealt with opaque facades and, in general, a big development. So in this case, we are in Wembley. This is a Wembley Park development, which aim was to achieve more or less 3,000 homes, to build 3,000 homes, so a big development in London. And as you can see, and here, of course, there were several drivers, several constraints. So there was a cost concern from the client. They wanted to keep the cost low, as also was mentioned in earlier on presentation. Cost is, of course, a key parameter of our projects. But at the same time, keeping a good speed of installation. But also, there was also an architect which vision was to have quite an interesting facade, so not losing the interest of the facade just to achieve a lower cost. So what we did in this case, we also did a sort of due diligence, in this case at early stage. So originally we investigated a build-up wall approach, so hand-laid bricks, windows installed on site, and the terrace fixed directly to the primary structure. However, this comes with some issues in terms of coordination on site between different trades, and also a risk of less quality if not controlled. Then we start investigating a precast approach, just having the precast panels already prefabricated in the factory, then the glass assembled on site, and then the balconies fixed on site. But what we ended up actually proposing at the end, and it was the final choice for this project, is what we like to call an integrated approach. What does it mean? We studied the solution of having even the balconies completely integrated and supported by the precast. And this obviously allows us to increase speed of installation, increase quality, but also minimizing as much as possible all penetration and thermal bridges, and also, of course, improving coordination on site and actually reducing the coordination needed on site because we have only one trade. So this process was, as usual, supported by engagement with the supply chain. We went to see factory visit, and this is a mock-up. And what we managed to achieve, as I was saying at the beginning, was also the vision, the intent of the architects. And how we did it? We did it by introducing some pigments in the concrete mix to achieve the color required, and also by thinking about an interesting mold to mold the concrete, essentially, to achieve what was the architectural intent. So we went on site, of course, and installation, and as you can see here, after the installation of those precast and prefabricated modules with integrated window, we then managed to bring to site the balconies and fix and support them directly on the precast. And then I leave to Michele our last example.
And the last project that we want to show, it's actually very, very close. It's in Pristina, here in Kosovo. And we think that this is a very good example to close because the way that the market operates and the type of ambition, it's really analog to the one that we are seeing here in Albania. And for this project, we are working together with the architect and the developer, and we are actually presenting the schematic design today. So this is being developed right now. And here, as you can see, the project is really driven by the use of glass and really pushing the boundary of glass in that specific market. So we have been engaged pretty on in the development of the project by the client, really to build and inform the process from the very beginning so that the architectural vision can really be carried through the project and make sure that the material and the constructability information were really in place from the very beginning. And we think that this is very important also for the Albanian market, especially where an international design practice is following mostly the concept and the early stage that then are moved to a local practice, and the more that we can build this expertise and this knowledge early in the process to make sure that constructability issue and even efficiency and budget sensibility can be built later on, the better, and the better way the design vision is carried to the project and preserved in the final stage. So this project, it's really a simple unitized facade, really defined by the use of glass. We have glass corner and the glass structural wall at the top, and we have been working both with international player for glass and glass supplies, and then local expertise in terms of unitized production and unitized facade. And this is just a view of the set that we're going to present today to the client, where really we studied all the typical details for the system to make sure that the design intent was carried through the design. And yeah, that was it from us. And if you have any question, please feel free to stop us outside. Thank you.
So these are what facade engineers can do. So they can engineer your building. Very pleased to see such a transparent building in Kosovo. I hope that gets realized and built the way it's designed. Okay, moving on next, we have a presentation titled Healthy Buildings by Alukonikstall. Their head of product management, Alexander Riemer. I hope I got that right. Is going to be talking. Please come on stage. So Alukonikstall are our presenting partners for the event. They are distributors of Schuko, Varema, and Rensen. And he's going to be talking on healthy buildings. Over
Thank
to
you very much. Good morning, everybody. Tite Mire. Well, not a building, beautiful mountains. We are surrounded by beautiful mountains, and this was inspiration for me to take this picture as the first picture. When you saw the title of our speech is Healthy Buildings, what is healthy? Is the building healthy for the surrounding? Is it healthy to be in the building? Is it healthy for the users? Or is the building healthy for the city? We don't know. Maybe I have some information which is interesting for you. What is a healthy building? Is a building maybe healthy if you have a lot of trees around it? First question. Is a building healthy when you lose a lot of steel instead of concrete? Is a question which is asked by architects and also by investors all the time, especially when it comes to so-called sustainability. Is it a Tyrolean mountain farmer's place, which is already 400, 500 years maybe old and still works properly? Everybody is healthy in this building, and the building itself does not need to have renovation. It needs maintenance, but not renovation. Or is it a printed building? Might also be an interesting idea to say it's healthy. Okay, or is it kind of this? One of the most healthy buildings, because you can buy it at Amazon or somewhere at 280 euro. It has even a window, as you can see here. Can we see? Yes, here. Cheap window, and you can remove it when you do not need it. Well, there is a book, two books from the Taschen Publishing, where you can see contemporary houses. Unbelievable, beautiful ideas, very similar, Marco, to what you showed before and what we have seen before. And my question is now, what should be healthy? When you look at a private building, also for a big building, it's the heat insulation, the control, ventilation, heating, a lot of subjects which you need to take into consideration. I think the most important subject is on the right side, the user. We saw minimum 2 examples before which are focusing the user, and this was very interesting. When you speak about this building, for example, it's in Vienna, it's the first high skyscraper, which is a zero energy house. It's the same questions on the right side. On the bottom, should be on the top, is the user. Okay, coming up, additional healthy. What is additional healthy? I brought here a brief story about Mr. Harry Glück. Harry Glück was an architect in Austria. He emerged to US, probably somebody of you know him. He literally was focusing on some things which made him in Austria very famous. He was working for the dense design of buildings, of residential and official buildings. He was focusing on the needs of the users, and this led to explicitly orientation of the architecture to the needs of people. I would like to show you two projects from him. The one project, I'm living there, and this is really nice to live there. It's a settlement consisting of 125 houses, only ground floor. Think about becoming older, not being able to go to the first floor, second floor, no elevator necessary. And the construction, the houses are almost 100 square meter, 80, 100, 120 square meter. The satisfaction of the people which are living there is very high. And the roofs are done in a way that we can add photovoltaic elements on it. Look at that, just 70 square meter photovoltaics with 14 megawatt per year. So this settlement can live on its own. And another project he did is in Vienna, maybe you know it, it is called Alt-Erla, where you see also very high level of satisfaction of the users, of the people which are living there. On each roof there is a swimming pool. This is one of the reasons. Almost every flat has a balcony. And this building is now under construction, it's renovated. The underground is there, kindergarten, school, everything what you need. Okay, when you speak about ventilation and acoustics, maybe you know that when you want to sleep, you would like to have a quiet surrounding. So is this possible when you're sleeping? Well, during the night, there are several possibilities in the meantime where you can break the sound, and you even have the window open in a tilt version. And this is not only during the day and during the night. You have this situation, as you can see here, with about 30 cubic meter per hour air exchange at 10 Pascal pressure. You see, during the day, you need it as well, because during the day you're in the office, or maybe during the day you're working in your home, or you're sleeping, whatever. The next image here shows surface temperature. Surface temperature of the facade is very important. We saw a lot of huge glasses, glass dimensions. You can have the glass or the facade inside uncomfortably cold, or you can have it uncomfortably warm. Please take this into consideration when you work on it. And much more important is the humidity in the room. You have a cozy zone, which is somewhere 21 degrees, 50-55% of humidity, and it could be too dry, it could be too moist. Next, why do we need ventilation? I brought here some example with you, and my colleagues know I'm always talking about. On the right side, you see the humidity, the water. On the left side, you see the CO2, which we are breathing. It is 20 liters of CO2 per hour and 35 to 50 gram water per hour. This is a mixture for you to have a sleep and to not, on the same time, sleep well. CO2 inside the room. Well, there are some rules. One rule says that the half of the room should be exchanged, the air of the half of the room, in 1 hour. In office building and schools, it says per person 30 cubic meter per hour. We all know that this is too less when it comes to, for example, a hospital. So you can choose active fans, controlled by automatic. In the school, hidden fans, which are just enabling the people to learn in a good atmosphere with fresh air. Here you see maybe a little bit on the top of the windows some kind of not visible devices. Well, looks like that. 25 cubic meter per hour is too less. Just maybe there is a heat recuperation inside this construction. How to ventilate? Next question. You have two possibilities of ventilation. You can say you make a cross ventilation for smaller flats. You can have a ventilation with an exhaust fan. That means somewhere in one room needs to be a ventilation system which is sucking the air which comes in by the windows. Or you can work like here in the hotel when you have a central ventilation. Just with the central ventilation, you know you need the tubes inside the floors, and that means the height of the floors is a little bit lower. Here you have a 3D presentation where the air comes in by the windows, by the vents, and is sucked by the bathroom or by the toilet. Well, there is also a possibility to work with passive fans. Passive fan is somewhere hidden in the window. And it is quite interesting. I say literally, you make a hole in your window, intentionally. You search for a window which has a very good heat insulation, which has a very high density, and then you cut somewhere a hole that you have more air inside. It's ridiculous a little bit, but it's necessary because we need to have a certain amount of fresh air in our rooms. Well, this is combined with sun protection, for example. You might have blinds there, you might have zip jalousies or whatever. Just don't block and make a barrier for the fresh air inside your windows, fixed windows or not. This small device on the right side is a CO2 meter. It shows you how much CO2 do you have in your room. And always keep in mind, CO2 is heavier than air. So it comes from the bottom up. When you're laying in the bed, it's a mess. I would like to give you one example. It's very interesting, I think. 3 times 4 times 2.5 meter room. Think about your office. Think about your private room. It is 30 square meter. What is going on here when you have a natural leakage of 26%? 26% of the room is exchanged automatically because the windows are untied. Well, if you have one person working in that room and you have this standard unseal situation, the green line means 1,000 parts per million, which is the maximum of CO2 which you are allowed to have in the room, because otherwise it's a bad surrounding. When you have 45 cubic meter per hour ventilation, you see after 2 hours, only one person. After 2 hours, you have the situation which is not good anymore. And only when you work with 72 cubic meter per hour, which is by law in Austria for hospitals and in Germany, Switzerland, then you keep the line and you work in a good surrounding and you sleep in a good surrounding. Something totally different. Maybe you remind that in railways, the toilet seats are made of stainless steel, maybe with a silver surface. We call it Smart Active. It's a handle in the hospital. When you grip it and you have a little bit bacteria on it, it diminishes from itself. A total different subject is the sun shading. We today saw a lot of examples concerning that. Just look to the past. The people in the past knew exactly how to cope with the sun. It's not necessary everywhere to make a blind. Maybe you have a deeper roof, maybe you have stones like in this building. So by the way, I must say I'm totally thrilled about the presentations which we had before. One of the possibilities is external blinds. With external blinds, and if you want to have a modern building, there are several solutions in the market which are interesting because you cannot see from the outside to the inside, but from the inside to the outside, you have a very good view, a very interesting view. And this is one of the possible solutions which are above blinds possibilities. These types of products all work with a similar function. The sun beams are reflected to the ceiling of the room so that you do not need to switch on the light, that you have a light room without electrical power. And when we are not want to use a kind of blinds, there are textiles outside. I think also you know that. In modern buildings, people like that very much. I'm talking here about exterior applications. I'm not talking about interior applications. The interior come later. This might look like that. And if you do not need it, it's up. If you need it, you put it down. Another subject, and this you have here on the sea, all regions where you have sea and where you have mountains, is the question of interior sun shading. We are talking here about sun glare. Sitting on a computer and the sun, remember, in the spring, in the autumn, is directly going to your eyes. We have a director in Alukönigstal who says he wants to go to sun gazing from time to time. Maybe you know that. He's stepping to the roof in the early morning and in the evening, looks to the sun and says, I do not need to eat something. This is energy from the sun. So the truth is, of course, that when you're working, this is not very healthy to look in the sun. This is a residence somewhere in the US. It is easy architecture. Just when the sun comes, they are able to lift it down. Another subject you have here on the sea. This is one approach. And in this image, you see how it is looking like when you have these things down. Problem is, as we said in the very beginning, the facade is sometimes the last part where you're thinking about. So the windows are the last part what you're thinking about, and then you have a window and you do not have any kind of sun shading there, so that means you need to do something later, and architect who thought about what he does comes then here and says, ooh, this is not really my intention, or this was not really my intention. Or in the mountains. In the mountains it might be even more necessary, because in the mountains you do not have only the sun, you have also the snow. So you have the glaring from both sides. And because of that, in hotels and places in the mountains, the sun glaring protection is as well necessary. You know that glasses, double glasses, triple glasses have some functions. One thing you must know, and a lot of people forget it always, if you have the sun protection inside, the heat is already inside. So the warmer the country is, the more you need to think about maybe to use both things, sun shading outside and glare protection inside, depending on the building. Okay, another subject is the operating force. All of us here are young people, most all of us, healthy, not handicapped. This will not stay. Hopefully, we will become older. Just there is a certain age when we are not so easy going to the window and tilting the window and closing the window. Almost nobody takes this into consideration. Mr. Glück thought about it. With Mr. Glück's buildings, you will have for private buildings no first floor, only ground floor. And here we are talking about the movement of windows. The industry provides several functions, several doors, window systems where you have a lower movement force to open and close the handle, a lower movement for opening the tilt. Think about today's glasses. The glasses today have up to 250 kilograms in a window. Do you really think that it's easy for you when you're 86 years old and not very fit to close that or to open it? This is a subject which we should think about. And another subject, which is called barrier-free planning, is the threshold. The threshold, we are talking about accessibility, find out where do I step at all, passability, nothing's impossible, maybe it's impassable, maybe you know that, and operability. So here you see balcony door, maybe the example which we had before, with a zero threshold. Please keep in mind, when you work with zero thresholds, like here, on a door, on an entrance door, you need to have some space where the water is running down when it's raining. So it's a beautiful picture. The technology behind that also must work. And some solutions are provided here in the market. When you look, for example, at this is the standard situation. Could look the same with aluminum, like PVC, like wood. You have a threshold, 12 millimeter, 16 millimeter. The European Union now speaks about 10 millimeter. In the UK, you have similar situation. More or less, the possibility is here that we work with zero. Not everywhere possible. This image should show that, because you need some space in the floor where the water, which is coming in, runs down and then going to a channel through a gutter away outside. So that means for renovation, this is maybe not the proper way, but for the new building it is. And if you have a renovation and you want to work with kind of these constructions, then keep in mind that you need to have a place where water runs out, especially when it's a region where you have hard rain. Here is the same situation like before, just it's not a balcony, it's a way out to the lawn. Possibly it's necessary, also keep that in mind, that these people do not want to go to the main entrance door. They want to leave the room by this balcony door, then you need to be able to close it. Also a question. Well, and IFD Rosenheim is not IFD Rosenheim if they would not find a rule for checking out this. And this rule has 6 classes. Somebody might laugh about that. When I heard that first time, I always was asking myself, is this now interesting or not interesting? Well, the guy who presented this was almost blind. And think about you're going with these devices, it makes a difference if you have 10 millimeter resistance on the floor or not. So the number 6 here means that this is a very easy passable floor. Okay, by the way, just one back. Did you know that that sign, I did not know that, the right sign stands for all disabilities which are available. You cannot hear, you cannot see, you cannot read, you mix up the letters. This is not only for the wheelchair. It's interesting. And they are searching now for a new image. So here you can see different windows or elements for handicapped people or weaker people. I will show you in detail. In this example here, you can see a handle which is positioned on the bottom because the people maybe are smaller. This handle here on the right side is a little bit lower. And on the entrance door, you do not have the handle at 1.50 meter, but in 80 centimeter. It's easier to access, not for standard, not for me in the moment, maybe later, who knows, hopefully not. And this is how it looks then in reality. These people here, the guests which came with the aeroplane, know such a door like this. When you look on the aeroplane and you come out to the taxi driver's place, you have a door which is, I don't know, 4 meter, 5 meter high. This is for sure not a healthy door, I think. And hopefully it is not used very often. The good thing is it is under the roof, so it is protected from the sun and protected from the rain. Good. Keep an eye on building automation. Building automation means you control what is going on with your windows. And this makes sense because you can save a lot of energy with that. Fine. All of this, what I told you, is now also interesting when it comes to sliding constructions. Few seconds before we saw a sliding construction. Here you see, zero threshold, beautiful view, going out. Okay, and the final page I would like to show you is this. Years ago, we were talking with architects about the most important subjects to keep in mind. When you prepare a building, we need to know the aim of the building. Input, know-how, use, and operation management into the planning process. We need to keep our focus on the whole life cycle. Integral planning. We need good communication, and we need to know good and efficient examples. That's it. Ladies and gentlemen, time. Thank you very much. It was a pleasure. All the best.
Thank you, Alexander. So that was Alexander from Alukonikstahl, our presenting partner. They have a booth outside, so you can meet their team and ask questions. We move now to architecture. So the next speaker is from Bjarke Group, Catherine Huang. She's a partner there. She's from their Denmark office, which is their head office, I believe. She's going to be talking about form giving and how facade innovation in architecture works. Come on stage. So she's going to be talking about the exciting projects her firm does across the globe. Thank you.
Thank you. Hello. Hi. Thank you so much for having me. It's a real pleasure to be here. And an even bigger pleasure to be somewhere sunny and not cloudy. I would like to give a little introduction about our office first, and then followed with some of our projects that we've been doing here and in similar climates. We are a partner and associate-led office of almost 900 now. Of course, founded by the guy in the middle with the great hair. We go through we have many different services, from landscape to architecture, products, planning. But what excites us is very much about kind of considering things holistically and how to make the city better by the buildings we contribute to it. It's exciting, of course, to work in the field of sustainability. And of course, we're good at certifications, but also in a more kind of holistic way. I also get very excited when we see our buildings in movies. I think we have a way of also creating kind of iconic but contributing buildings at the same time. And speaking of superpowers, I think actually one of our superpowers is having so many different nationalities and backgrounds in our office gathered together to contribute different ideas and different ways of thinking. And here is one place we gather. It's our Copenhagen headquarters, which if you're ever in Copenhagen, I would invite you to come visit us. It's not a standard office. It's more reflective of how we work. It's an office that speaks to collaboration of finding your colleague on different floors and communication. And that's also what we bring to the table at BIG is a way of thinking about architecture that's maybe not a standard way of thinking. So here is a building that we can see from the windows of our headquarters. This is actually a ski slope that we've placed on top of a waste energy power plant, almost with a kind of Swiss landscape on top that you can ski on. It's brought back a lot of biodiversity, and it's thriving because we considered how to activate a part of the city that was close to the center that is also contributing to the kind of extreme sports in the area. We also look at ways of solving problems that you might not know even exist. This is a sculptural museum that acts as a bridge that completes the circulation of the master plan in a sculpture garden in order to kind of allow people to visit the site without having to double back. And we find these solutions through kind of collaborative dialogues with clients, iterative repetitions of models. And we do this through different scales, from product scale to planet scale, and different parts of the planet as well. And that's why that kind of brings me to a close on our introduction. But I want to talk to you about kind of a few other projects. And you can see that we sit in Copenhagen, where the blue dot is. But what I'll try to talk, like many of the other wonderful speakers today, I'll talk about kind of warmer weather projects that we have both in Albania, but also in China. And this is, I hope, okay, because I'm not actually from Denmark and I'm from Texas, so I can speak a little bit to the warmer weather projects we have. So one of our projects, like many others, is located on the boulevard. It's a bundle of columns, stone columns that come down in a geometric way. The really great thing about this is that it's also kind of referencing quarries and landscapes available in Albania. But it comes down in a way that activates the ground floor plan in a way that kind of creates community and as talked about earlier, kind of attractive ground floor to kind of activate the city. The other thing about that is it immediately takes care of kind of a window-wall ratio that usually glass towers don't have in the same way. We have an efficiency in terms of how much thermal gain we have and how the performance of the building works. In here, we've shaped the columns to open up for views out. We've also created cutbacks and terraces so that you have places where the terraces come in and then landing trees on the top of the columns in order to almost get a kind of overgrown like a vision of a green ruin, but very active and a great part of the city. And in doing this, we've also kind of looked at becoming very smart about how we use modules. Everything is a module. We've limited different types in order to kind of create something that feels very alive and very vibrant and very unique, but still with various standard kit of parts. And in the shadow, you can see alongside this development, we have a small office building, which we wanted to make as a kind of sibling building. So related, but also not. It's organized around a general, like a big atrium space that carries you up through the lobby. It also takes reference from different kinds of rock formations that you have this kind of almost mountain pass to the roof garden, which is a public garden. From the boulevard, welcoming you up all the way through these public stairs to experience a slightly more public building. And doing this, we wanted, of course, like we said, a sibling building, something that was similar, but also had its own character. So here what we've done is instead of having open columns, we've actually kept it orthogonal to the building, given it a better actually performance in terms of solar gain, while not needing the same kind of views we have in the residential portion of the projects. Again, you can see that the window wall ratio is very controlled through this kind of facade system. And it also allows us to use large pieces of glass without breaks in it, economically, but still feeling very expansive and generous in order to create a very kind of tectonic result. The other way we've set this building apart is through the creation of kind of vaulted beams, because it's more of a public offering, kind of wanted to symbolize something a little bit more civic. So we've looked at these kind of vaults that run one direction through the building. So on the boulevard side, you have these beautiful arches. On the two kind of peripheral sides, they read as actually a bit more strict and straight. And then again, in the corners, we cut them back and have a kind of shortcut through the corners and open arcade to, again, activate the ground plane. We've controlled the amount, again, through modules, a modularity of 6 different vault types that populate the entire building. But they carry a kind of, with just 6 types, we feel like it carries quite a beautiful kind of atmosphere, a character to the spaces, both the modular spaces and as well as the kind of more auditorium type spaces, all the way up to the roof above. And now kind of moving from the city, now we go to the coast in a way of how to translate similar ideas into a more coastal or resort typology, taking advantage of the views of the water, trying to also create value through the shading and the relationship to the water. And of course, it's very important to have these terraces and views out. We focused on a system, again, that kind of pulls from a beautiful kind of terraced roof all the way down in order to activate also the ground plane again. So something very embedded within the urban context. But I think the main focus for now, right now, is the kind of tectonics of the kind of arched terraces and balconies that we've created. And again, working in a smart way through modules and similar units. We actually found some pretty interesting things. If we wanted to create these kind of overlapping arches, what it meant is that we had to skew the grid, which was a little bit unexpected. And then actually everything moving through kind of the development stage of this project was actually in order to try to kind of align this kind of stepping grid with, so that we could have a smart system to create this kind of cascading effect. But I think we've managed to solve most of the issues so that we have kind of a very clean system of units, both the kind of normal hotel units, but also the terrace units above, creating this kind of amazing views out, and even using the greenery as another architectural element in order to limit views and create privacy. We've done these kind of view studies in order to kind of make sure that everybody has their own kind of private paradise in these kind of large, expansive terraces. And from here, this was also a warm climate. We'll go even warmer to Suzhou, which actually I found out is on the same latitude as my hometown in Texas, which was surprising for me. So we move into another kind of not a coastal offering, but it's alongside a lake. This is a kind of public building that sits next to Jinji Lake in Suzhou. It's meant to be a meeting point where you have kind of a coffee shop, public services, like tourist information. And it's always been envisioned to be similar in concept as the other ones, an extension of the tree canopy. This idea that we create a sheltered, shaded place for people to gather. In the four corners, we have generous openings that lead into a very kind of contained and well-sheltered courtyard area. A perfect place for gathering and for taking a coffee. We also managed to get these beautiful kind of high glass pieces. But actually the focus of all the research was in the kind of roof datum. That was actually quite a challenge because we always knew we wanted this kind of dappled effect that you get through tree leaves. But we weren't sure how to get there. And we actually went through many options that I won't go through, but most of them being rejected for sustainable reasons or for constructability or for the fast timeline that we had to maintain. We actually started with the idea of a clear story. Then we had to move into something that was perhaps more kind of integrated with the structure. And then we thought maybe some kind of double layer. But none of them quite reached what we wanted until we found a conceptual idea where we wanted to have 2 layers of perforation that somehow would create a moire pattern between the 2 of them, hopefully leading to an effect that was a little bit more like what we were trying to achieve with the tree leaves and the kind of filtered light effect through the roof. But even though we knew now what effect we were wanting, we also didn't know what kind of material to use, so we went through a whole round of different materials from mesh interlays to foamed aluminum, and then to perforated aluminum, and where they would sit in relation to the glass and into the roof. And finally, we managed to come up with a kind of IGU system for the roof and a soffit box underneath to create the 2 datums. But each datum also had to do a lot of work in order to kind of take care of all the thermal gain and make sure that we had a operationally efficient building. And in the end, what we found was an aluminum interlay, you can see on this side, between the IGU and then a soffit box made out of steel to keep it very clean underneath to create the kind of moire effect, but also to hide the services in the roof structure. And the final final detail looks a little bit simpler, but actually a lot of work and a lot of iterations through the whole process. But I think we went through maybe 10 different iterations of what it could be with 10 different mock-ups. And I think the final solution actually we're very happy with in terms of how it feels like a canopy of leaves that comes down and shelters the space. And then from here, we actually take a 10-minute walk down the lakeshore to our newest kind of cultural project that we're unveiling, or with a grand opening in June. This is the Suzhou Contemporary Museum of Art. And it's actually also conceived around this idea of how to create a sheltered, welcoming urban space that goes that flows seamlessly from inside to out. Of course, taking some cues from the lakeside, but more importantly, looking at how to create favorable microclimates, how to connect different volumes in a very seamless and pleasant way, and also just how to give the city an attractive place to occupy, even in the summer. And if we take a step back and look at what Suzhou is a very interesting city. It was a metropolis when Shanghai was a fishing village. And it has a deep, deep history, but also a very contemporary bent. It is the historical birthplace of kind of traditional Chinese gardens. So it's actually a UNESCO heritage site for these gardens. They are they're beautiful, and we wanted to make an homage to them as part of the design of the building. So instead of a kind of traditional hermetically sealed volume for a museum, we looked at how can we disperse the volume and how can we create almost a museum in a garden, but also holding a garden, so that we have interior gallery spaces that are supported by exterior garden galleries for sculptures and art as well. So in doing that, we also looked at kind of traditional motifs in the gardens. We have the idea of these garden paths. In Chinese, they're called lang, which I don't know if you grew up with Chinese movies like I did. That's where all the kung fu and the flying around and fighting happens. So there's a really great kind of connection in culture for me for those. And then, of course, the gardens themselves, and then the pavilions that you occupy. And we thought, okay, but what if we could use those kind of beautiful walkways as as everything? So they would be walkways where they surround pieces of landscape. They become gardens, and where they condense into volumes, they become the pavilions or the galleries that would hold the artwork themselves. And then that also led us to kind of Chinese knotwork as well as paper cutting, all kind of Chinese crafts in traditional, but also in contemporary art. And the idea that the roof should almost appear as kind of Chinese knots and a floating kind of paper cut over the landscape. And this is a render, but we're also really pleased with the way the reality has turned out, that we managed to keep this kind of floating aspect of it, and that it also creates these kind of sheltered areas. And then one other thing you might have or not have noticed is that we're sitting behind a Ferris wheel, because why not? Of course. And at first it was very difficult to kind of reconcile the design with the Ferris wheel, because it blocked all the major views, but it also became, in the end, a reason to kind of distribute the different volumes around the Ferris wheel in order to kind of frame and take advantage of the waterfront. It also meant that we really had to work very hard on the fifth facade, because everybody was going to look at it when we were up in the Ferris wheel. So if we focus on that fifth facade first, we look at the way we created the roof. And it was very much created out of kind of repetitive elements as much as possible. So everything is an arc length, very controlled geometries, where we were able to also kind of categorize the galleries into types, and then subdivide each of the kind of arcs, the roof planes, also as types, and then of course the free-flowing canopies as well, and then also modularize that on a 1.5 meter grid, and then from there to create the kind of panelization of the roof in a way that actually, so we went through a few rounds of this as well, in order to kind of cost reduce dramatically. We went from I think 20% curved panels to 3% in the way that we worked together with Front to kind of create an efficient system of panelization. But also, in addition to the panelization, we actually had a lot of coordination with our local architects, local collaborators for drainage, for the mechanical system, You can see a huge drainage ring, the kind of mechanical pits, in order to get as clean and as flawless a kind of roof surface as possible. Something that almost just floats, where you don't see any of the surfaces. Was a huge kind of collaborative teamwork, which we most of the time enjoyed very much. In order to kind of create something very, very clean. You can also see, this is still a construction photo, but you can see that this is actually where the mechanical system kind of vents out. That is an entire mechanical building, but that you really disguise through the perforations, the interventions on the roof. I think the other thing that really struck us in the process was that we only were able to get such quality through intervening in kind of material selection and material selection through the whole process, from control samples to mock-ups to VMUs to factory inspections and to the on-site kind of execution of it. The materials were a huge part of it in terms of creating the quality. It was also a huge challenge because everything had to be on a 100-year kind of cycle. So everything had to be very durable. And the fire kind of, fire regulations are also very strict. But we fell in love with a lot of the different materials. We developed them together also with the steel producers and with the glass producers. These columns actually support the roofs and became a very iconic and beautiful part of the material of the building. The glass was also developed together with the glass factories in the area. 1.5 modules that are curved, triple layered glass, and then fluted to create this kind of dispersion. And the great thing about the glass is that we also found all these kind of effects that were a little bit unintended, but actually played really well with the building. So the glass at first was actually meant to be more of a kind of ripple and homage, again, a reference to the water surrounding it, and a way of kind of floating the roof. So somehow dematerializing the volume of the building in order to emphasize the roof. But in the end, it also became quite its own element. In terms of kind of restrictions, we also had to play a lot with sustainable issues. We had to, again, deal with window wall ratios. So this is a diagram of what's open and what's closed. Here, we wanted everything to be of the glass aspect, so we could float the roof as much as possible. We had two main glass types, or wall sections, wall types. One, which is the clear vision glass, both rippled and not rippled, up to 7 meters high, where we've integrated actually the shading elements in the mullions themselves. And then kind of also the shadow box, where we control the light coming in. And where we have the shadow box, actually one thing that we learned, again, with the materials is we used raw aluminum for the back. And that created something that was so alive and vibrant that you almost couldn't realize that it wasn't true vision glass. Along the way, we learned a lot of great things. The kind of refraction and the light you get from both the curved and the rippled surfaces became something really exciting. It was also great for directing views. You can see the corners are open, but then we've actually created a gradient. So there's the rippled glass on the side directing your views inwards. And then the other great finding was actually, because of the curved elements, we always reflected light from all around the building. So all these sources that you would never actually anticipate being reflected in. So you can see actually the sunset in a facade against the blue sky. So we were taking kind of light from everywhere, and it was becoming quite a chameleon of a building. And it was and it's a great kind of thing to experience in person. And the last thing is because of all the knot work. We found that it was becoming such an exploration of the gardens and of the buildings, and just really great to kind of find different vignettes and different kind of experiences that you would not normally find. And for us, I think, and for me, that is actually one of the best and biggest goals for architecture. So I'm actually on time. Thanks. Thank you.
Thank you, Catherine, for that excellent presentation. I'm sure your Tirana project will also have a lot of innovations once it's built. We're going to move to our panel discussion. That's going to separate you from lunch. It's going to be a quick 30-minute panel discussion. So while we organize these events, especially in new locations, we try to find people who can give back to their country. And when we started curating this program, we were looking for Albanian facade consultants around the world who we know in our network and who have been responsible for projects in other parts in which they can come and give it back to their country. One such person is Nicolina. She is from a company called Arcora, one of the leading facade engineering companies in France. I recently got to know that she's Albanian. So she's going to be our moderator for this panel. The topic is basically on local approaches with a global perspective. She's going to be moderating this panel, and she's going to be calling her panelists on stage. So over to you, Nicolina.
Hello, good morning, everyone, and welcome to this last panel. We will be discussing what it means to design architecture in the Albanian context and how it connects to a broader global perspective. So Tirana is a very fast evolving city shaped by strong architectural contrast between the Ottoman architecture, the communist era architecture, and the developments from the last 30 years. There was a major point, which most of you know, in the years 2000 with the introduction of the urban master plan, which placed this axis of high-rise buildings, and it opened the door to international competitions. And thanks to that, new projects with very strong concepts started to shape the city's identity. Every building was supposed to be an architectural statement. And it also placed Albania in the international architectural scene, in the map somehow. It brought global architects that, like many international architects that we have now here, that collaborated closely with local ones, with the company constructors, with engineers, and with the local actors generally. So at the same time, this process, and we built what we have now in Tirana, so many high-rise with glass, with very modern facades. And at the same time, on the coastline, on the seaside, there was a very different architectural approach with smaller buildings, but with a very unique architecture that links to the Balkanic and to the Mediterranean architecture. And also the use of materials was much more local. This panel will explore that dialogue between the global and the local, between architecture and engineering, and particularly through the lens of facade engineering. So we will discuss what designing in context means today and how to balance global knowledge with local realities. So let me introduce our panelist. It's slightly smaller than what it was supposed to be, but nevertheless, very interesting. We have Edlira Basha. She's head of design and development at Orion Construction and recently co-founder of Triarch Studio. She has led major projects in Tirana, including the Vet Hospital with Davide Maculo Architects. So she knows something about international collaboration, I suppose. And Enrique Mascor del Pozzo. Enrique works for Ricardo Bofill Architecture Studio, based in Spain, in Barcelona, where he leads many projects across Spain, Eastern Europe. He has been in Africa for work and increasingly in Saudi Arabia.
Correct.
He has over 17 years of experience in major urban and cultural projects, including museums, city regeneration, and has been working in more than 15 countries, one of them being Albania, because you are now constructing many, you have a few ongoing projects here in Albania. Yeah. And me, I'm Albanian. I'm an architect and an engineer. And I work at Archea, which is an engineering firm based in Paris, with more than 50 years of experience in facade and complex structure engineering, where we design complex facades, structures for both buildings and new buildings and renovations, with a strong focus on reducing carbon footprint and improving performance. Archea has been working in many projects, mainly in France, now increasingly in Saudi Arabia. Many high-rise buildings, such as Saint-Gobain Tower in Paris, or La Marseillaise, which is done with Jean Nouvel in Marseille. And more recently, we work in Saudi Arabia with Ricardo Bofill office, and in many other cultural landmarks, such as the Philharmonic in Paris and Le Monde headquarters. So with that being said, let's dive in our panel discussion. The first question that I have for you at Lira, when you design for Albania, what shapes the most the approach that you have towards architecture, and especially towards facade? Will it be the climate, the culture, or the available technology of the market?
Well, being head of design and development department at Orion Construction, which is a real estate developer but also a construction company, my main responsibility during the years has been to check whether to receive good architectural proposals, but also to check their feasibility, their costs, and work with the architect since the beginning in order to have a project that complies with climate and all the local materials. I would like to share with you here the example of one of the good buildings already built in Tirana. It's Orion Business Center. It's the headquarters of the company, and it has quite a story about its facade design. So the company had bought some terracotta tiles from Sanine, many of you might already know, and these tiles were in stock from a Mario Botta project, so there was a quantity of 3,000 square meters. We also, in the meantime, we organized a competition about the project of designing our headquarters in Rugheco Sovarve. Probably some of you have already seen the project. And the winner of the competition is an Albanian architect which had worked to Mario Botta for some times. So it happens that we had already the tiles in place and we had a project. Nothing was still decided. However, we designed, this site was quite small and it was really, the main facade is oriented through the southwest, so very hot, very sunny. But there was no much space for designing some deep lodges, and it would also be office, so we didn't have enough area to lose in external areas, spaces. It comes out, but just by chance, that the quantity the project needed was approximately 3,000 square meters of terracotta tiles. So Adurim, who is the architect, fits all the tiles into the design of the facade. And now it's built. It was about 7 years ago that we were still designing. And then having this kind of tile, which was, however, heavy, we asked to have the substructure project from an Italian company because we weren't confident enough in Albanian designers on the issue. And we waited several months. We received the project, and then we had to do the feasibility study of getting all the necessary materials and all the costs. And it comes out that there were too many inox elements and some heavy elements that we had to import from Italy, and the cost was slightly higher than what we needed to achieve. So then we start searching once more in the Albanian market, and we find this very good subcontractor. And after he studies the project, he takes the responsibility to design and realize the substructure. So it all started. We were convinced. We did all of our checking with our internal engineers, structural engineers, and it worked. So we started placing the facade, and it lasted a bit longer than what was foreseen, because shortage of workforce is something already happening in Albania from a few years now. But now we have an important landmark for the city. So we also worked closely with Shuko in order, there are large windows on each floor, and we chose the right product and the right glass from Sun Guardian in order to keep the heat as much as possible out of the building. So
that's a very interesting
yes.
example. So you had to some sort of recycle these plates, these tiles, and then be able to find Albanian subcontractors to realize it. That's what about you, Enrique?
Well, first of all, thank you so much for the invitation. It's always a pleasure to be here in Albania.
It's the Zak that invites.
Yeah, and well, the question asked about what's the most important point in between climate, culture, cost, or available technology. No, my understanding is that everything is strongly connected. No,
Of course.
Logically, climate affects a lot the culture, affects logically to the available technology, and then to the cost. So everything is kind of related. But since our office, Bofili is so human-centric, so much based on the human experience of the building, not just of the user, but also on the pedestrian walking the sideway, or on the person who is entering into the building. And also, buildings are like systems, no, like systems that go from the outside to from the inside, to the outside. Facades is strongly important. And if we had to pick it to someone, it would be culture, no, for us. Doing a building is like a cultural operation, especially if they are on a really important area in the city, like some projects we're working on. And for us, the most important point at all is the culture. No? If I can maybe extend very, very quickly, no? I also wanted to say that, well, it's not logically the same working in Europe that working in other continents. No? We just finalized a project in Africa, no? In Benin, no? And the conditions there are absolutely different of what we can have here in Europe. No? One may think that you can build with all kinds of materials, whatever you want, if you have the right budget. No? But we don't feel that this is the case. No? We feel that there is a very important vector that is maintenance. No? It's not just about doing a beautiful project, it's about how this project is going to be run day by the users. And we feel that it's an obligation to help them on this regard. No? In the specific projects of Africa, of Benin, that is a university campus, we did it from the day zero of the project with the intention of using local materials, not just national materials, but materials that were produced on the right city where we were building them. No? So that's something that we feel is very, very important, but always related with the culture. No?
Yes. And did you have any local constraints that would limit your design choices, or did you have some moments when you had to change your design because you couldn't find the people, you couldn't find materials?
Completely.
Do you have to improvise when you are in this kind of cases?
Completely. By the way, we are right now on the process of testing a lot of mock-ups for Albanian projects with many amazing local manufacturers, and logically there is a process of testing them, of learning more of the local systems. Of course, there are situations like this one, no. But I want to say that, for example, we have another project that is in Duros, no, in the beach promenade. No, we're doing like a canopy, And on the very beginning, we thought that we were going to need to subcontract all that to Italian or Spanish or other companies, but we really did a conscious effort to find local companies. It took more time, but now we found an amazing company doing pigmented concrete. It's like in a special blue kind of color, and each project is right now in construction. Maybe in some weeks it could be possible to see the final result. So answering to your question, yes, sometimes we need to change plans, of course.
Why did you insist so much to find an Albanian company? Because, I mean, you would have had a guaranteed result also by bringing another company in.
Well, our approach is that, first of all, the maintenance we feel is essential, that if there may be any kind of issue in the future, it can be resolved locally, not having to import something from outside. And secondly, because when we do a project, for us it's a really cultural operation where we really want this project to be made in Albania and to be a really Albanian project. It's not like a foreign thing coming here. No?
Right. And why do you think places with very similar conditions and climates end up with different facade designs? I'm referring here more to the Balkanic context and to the Southern Europe context. Obviously, Tirana had chosen a very different path to developing architecture and facades that would have had, I don't know, our neighbors, let's say.
Well, of course, major decisions, political decisions also affect the way Tirana and Albania is being developed. We started collaborating with international studios since 10 years ago, and we started this collaboration with Davide Maculo, for example, and we have already built some of his projects in Albania. But the process was, as Enrique was saying, very interactive. So the architect heard what was possible here, what Albanians knew how to do better, and many details were adapted to our way of doing, because of course you can also import and do new things, but you're not sure that they're gonna manage or do it in the best way possible. So the risks are higher when you introduce something new. For example, we have already built another BREEAM certified building in Albania, the only one that is only offices, already finished construction. And we wanted to have there, it's a 20-story building of offices, and we wanted to have there natural material in the facade. But the architect had already designed something taking into account the sun from east or west, because it's fully orientated, and the facade changes according to the sun and the colors and the shadows. So in the western part there are more filigranate elements which do the shading to protect the glasses and the windows. So having stone ventilated facade there was not so smart, because many of the elements weren't directly perimetral, weren't part of the external wall of the building. They were just protecting from the sun. And so we started thinking about doing the whole building in pigmented concrete. And it was a challenge. It took 6 months to study on how to do it, starting from the construction engineer. And then we talked to all the companies who produce the concrete, and we found out, after many mock-ups, many color variations, that it would be quite difficult, because in such a big building you had to provide all the first materials, the raw materials, so sand, to have it already in your storage, so the color of the concrete wouldn't change during the different phases. So this thing came out, but however we had already went on with the design and already started constructing, and at the end we realized a concrete building, and to polish up the imperfections we already also added a paint a white paint which still allows the concrete to be seen. And now it's quite a beautiful building, a landmark for the new boulevard. It's being BREEAM certified, so we also took care of the carbon
It's the
footprint.
first BREEAM
It's the first
certified in
BREEAM
Albania, right?
certified, yes.
Yes.
Works are finishing now, so we're finishing also the final certificate, the BREEAM certificate. But it was quite a journey to reach this point, and many efforts were made, not all of them successful, but of course we learned a lot and we managed to do a good and certified building at the end.
So basically here the climate
Yes.
element was very important, I suppose, because of, and we see that a lot in so many other projects that
it decided the design, and then the facade is out of
it has
that,
to follow
of
up
course.
in this sense.
Yes.
Yes, Enrique, what would you have to add on this question?
Well, I think it's a very good response,
All
the
of
one
you.
you have. In our case, for example, we like very much to be very honest with the materiality. You know, we are very much about, as other architects said before, that if we use, for example, a concrete structure, we like that to be also the facade. We don't like doing claddings with other materials that are maybe not the honest structure. No? And in this regard, we've been working a lot also here in Albania. We did a project, by the way, with Atelier 4 also. It's like a pavilion for the Albanian presidency for international guests. We finalized it some months ago. And in this case, what we did was not to demolish an existing building that was done approximately in the 60s, but to enhance the historical lay of the building. I don't know if maybe there are some pictures here or not, but what we did was not so much to paint the concrete structure, but to apply some kind of glazing that are like translucent painting that provide a new level of color, but also allow you to continue reading the historical building. No? And for that, I have a short story to tell. We have some issues also finding the right people to apply, but finally we resolved it by bringing one technician from outside and then teaching a lot of local painters to do that. And now the local painters are painting even better, no, than the original one. No? So in this regard, I completely agree with Elira that these kind of collaborations are amazing in both sides of the relationship. No?
What design strategies can travel across the region? I mean, I think you have the perfect answer, because Bofil Studio applies sort of the same aesthetic, which is this Mediterranean aesthetic.
Correct.
And you have been building some very...
Correct, but anyhow, even if we are also in the Mediterranean, there are also some very clear specificities about each corner of the Mediterranean, and the fun thing is that we are learning so much from the Albanian vernacular architecture that we are also applying to projects in Spain, for example. Now, this image here is a project in the south of Albania, in the coast, that, as you perfectly say, is a very different kind of architecture. Here, for example, the maintenance is a must, because this is not an office, this is not a hotel. Those are like residential for families. And here we wanted to, with contemporary architecture, but traditional systems, to resemble a little bit the complexity of the city, the complexity of the Mediterranean towns that you can find so amazing examples around. No? So you are completely right. No, we always try to mix our cultural backgrounds and to try to create something that is contemporary, but at the same time use local materials. And this is something very important for us. No, we are on the continuous search for artisans, for crafters, local crafters that can really apply this on the modern architecture. For us, it's essential to keep this profession. No?
Absolutely. How are facade systems in Albania evolving to become more resilient and to adapt to the challenges, such as material sourcing or climate change? It's a big issue. Albania being very hot, and in Southern Europe countries will be hitting more and more, and above all, shortages in labor, in workforce. I don't know how much is that a problem in Albania.
Yes, it's a big issue in Albania, but we have the lack of collaborating with international architects, starting from the challenge of global the weather warming. So all the experience they have, all the experience they have made in different parts of the world is coming to us in very fast rhythms. So I think Albanian architects, Albanian constructors, and everyone who's working in the building industry, and many of us are part of it, are having a great chance and opportunity and benefit to receive this know-how and to work to see the projects done. So I think that's very important, even for us as architects or constructors. So their experience brings a lot of good, to the projects. Workforce shortage is something we deal with every day, and it's becoming difficult. But it's good to see that, however, even Albanian constructors are understanding that the labor force needs to be better treated with higher payments in order to keep them in town. So I see that there's a change, a quick change towards that. So people are being paid more, being offered more, better working conditions in order to keep them, because there's a great quantity of work to be done here. So it's going to be a challenge, but it's important that we're reflecting
and
in
more
that direction.
security to the workers, and above all, also having education, the schools that will form this. But this, of course, is not up to you. It's up to the powers to think about it. Right. So, is it? Well, you said it over and over again. But is local sourcing something that is really realistic, or more of an ideal? How much of your materials you have to bring from out?
On the very beginning, we used to source a lot, but we are really trying to source less and less and have all the operations here, and that's the reality. We're really trying to do all we can here. We are in the search for nice ceramic products, for some kind of stucco products that we can use, for example, in the red project that we were looking at right now. And we are really, we have a local team here already established, and they are in the hunting for the perfect suppliers in a way that we don't need to outsource so much. This is something that affects sustainability, but also affect to the cost, because if you have the companies around the corner, logically you don't need to pay so much. Also, the timing for the arrival, for the logistics are going to be much less. So we really think that it's a win-win scenario if we try to do everything locally.
And one last question. How do you see facade design evolving in the next 10 years, let's say? It's a long enough time to...
In the context of Albania?
In this context, Albania and even more generally, Southern Europe. I mean, we do share the same concerns.
Okay, I think that, well, it's going to be getting more and more professionalized. Logically, BIM and Revit and all these parametrics issues are going to be every day more important. But, and in this regards, in this professionality of the profession, that's a positive thing. But I also want to worry about possible bad things that may happen. No? And it's what I say before, no? That we may lose some amazing artisans that are currently working with the timber windows, with the painting, with some kind of details. And ideally, what we would like to see is a more professionalized sector, but at the same time, a care about these professions that needs still to be there, no? Not just for making things made in Albania, but for doing architecture that is really Albanian and is not completely standard and it could be from anywhere else.
Yeah, that's absolutely an issue, and especially people that are retiring. It's actually a big issue. So, what is your vision on the facade evolution?
Being more focused in Albania, as I already mentioned, I see there's a very fast development. Every time we're receiving also proposals from other studios about building a 50-story, and I understand that from the point of view of an architect of an international studio who has already designed and built this, it's easy. But when it comes to the constructor, not having this previous experience, it's a challenge, and you have to study everything from the beginning. And also facade design is something I think we need to develop deeply, because wind changes, wind force and sun shading and everything. We do not have this experience of all glass buildings in Albania. I see with great pleasure that, however, international architects are, every one of them is taking care of the climate here. But however, there's still a lack of know-how and knowledge that is being developed very, very soon. So I think that in 3, 4, 5 years, when many of these high-rises are going to be finished, Albanian professionals are going to have a much better experience and much better know-how in the country.
Yes, absolutely. So thank you very much for being here and for not abandoning us. And I would like to thank all of you that stayed. And I understand now it's lunchtime. So it is very clear that Facade today is not just about the performance and the aesthetics, but it's also about adapting to all the new constraints that we have linked to material shortages, to workforce shortages, and to climate change adaptability. And this is a worry for every country, and especially for the Southern Europe countries. And for the next 10 years, most probably will change the way we design, the change we live in our buildings, and how we build the facades, and how we maintain them, and how you build them, actually. Well, thank you very much.
Thank you.
And we are right on time. Thank you, Erika.
Thank you.
Okay, yeah. So welcome back to the third session and the last session. We've got 4 presentations. We've got 5 presentations and 1 panel discussion, all different topics. I think we'll start with the first presentation. The first presentation is from Luis Garcia from OODA. OODA are a leading Portuguese architectural firm with several projects in Albania. And Louis is leading the office here, the Tirana office of OODA. So he's going to be talking to you on performance and identity, integrated facade design in emerging urban contexts. So
thank you very much. First of all, I'd like to say thank you very much for having me here today. My name is Luis Garcia. Thank you for the introduction. I would like to take a few points here to discuss with you guys today. The first thing is our genetics, the way how we work, how our office work. And the second phase, and the second part of the presentation regarding the facade design, how we think our projects regarding facade. And I'm going to show you guys 3 projects that we have here in Tirana. And those 3 projects are towers that we have. 2 are already under construction, and 1 is under development. So who we are? We are an architecture firm base. We are in 3 major cities right now. Our founding partners found our office in 2010 in Porto, Portugal. So this is our headquarters at the moment. We have another office after a few years. We open another office in Lisbon, the capital of the country. And now we have our most recent one here in Tirana, which I'm the leader designer of our projects and director of the operation here. Our projects go in a very different scales. We like to think architecture as everything. So since we design a furniture, going to a house, or going to a master plan or urban plannings, we need to think also all in detail. So our office goes through all these different typologies of projects. Our organization right now is in a horizontal way. We think that giving voice to many different levels of architects and different people are the main goal for us to deliver a better and good quality architecture. OODA is not trying to seek one single signature. We want to be a brand that with our strong methodology that we have inside of our office, we are able to give excellence in architecture. Here is a video that I'm passing through with a few projects. This one is the Clan TV competition that we won in 2023. It was our first competition, and we got the first place. And not just these kind of buildings. We do, as I said, a bigger master plan. This one is in the Beato area of Portugal, in Lisbon. And all the time when we start conceiving and thinking about one project, we need to understand his context. We need to understand what we have in the city, but just not around the context around. We need to understand the city. We need to understand the country. So inside of our office, we play with many different tools to achieve the better quality of architecture. And this tool goes by hand drawings, for example, which is a Porto School of Architecture give us these hand drawings. The first thought that we have in our mind, we put in our paper, going to the main new technologies that we have here today, like BIM, 3D model, parametric model using Rhino, Grasshopper, Revit, and going now, we are trying to implement also in our office artificial intelligence. In our perspective, a good quality of project needs to join sustainability, community, history, and value. We think this mix of those important words combining, we think we can create a local intelligence with our project. At the same time, this is going to be a global reference. For us, architecture is the art of building buildings, but just not that. We think architecture is storytelling. We need to create a story with our projects. And this story needs to fit very well in the site and fits very well in the urban fabric. The second part of our presentation, I will discuss about the facade design. And with the three major projects that we have here in Tirana. So I would like to talk about volume, envelope, multi-layer and shadows, and dynamism and transparency with these three projects. The first project I'd like to introduce you is the Bound Tower. I would say that it's one of the most elegant towers that we're going to have here and in our office also. The second one, Ora Verticali, the most complex one that we have, and Daria or Split in English is going to be the third one. Could you turn down the volume? Okay. So the Bound Tower. The Bound Tower is a tower that we have here. He's here in Tirana. So the main concept of this tower is to be an elegant tower. The plot is very small, and we need to build a tower with 200 meters high. So our concept here is to have two main volumes, and the highest volumes is 200 meters, as I said, and the small one we have 165 meters. This tower is implemented in a avenue called Dritan Oksha. I think I pronounced right. This street, this main avenue, connects to the airport, to the main, to the downtown of the city. And we know that in a few years, this whole street will be transformed. We already know that have a lot of other great architects doing towers and buildings there. So in 10 years, this whole sky line will be 100% different. As I said, the main concept is to have a really thin and elegant tower, and we think here we have almost near to the base of the tower, we have this plie movement that are really reflecting the movement of body and the movement of someone dancing. And we believe that creating this movement, we can break the messiness of a conventional skyscraper. And creating this void will have more freshness. The project aims to integrate to the urban fabric, and not just this, but to keep the identity of the urban living in Tirana. We know that we have a lot of coffees. I think Albania people, I'm living here, and I can say Albania people know how to use the public space. And we want to bring this in our project, having in front of our tower public space, a square, and inviting people to join. The project is a mixed use, so it's increased even more the possibility to have movement in the tower in different periods of time during the day. And we have here in the video, you can see we have a rooftop. And regarding the facade, the main concept in the facade is the textile. We know that the patterns and the textile here in Albania are really important. It's part of the culture, and it's not just part of the culture, but it's one of the most important commodities for the country. So we like to bring here with this parametric intertwined skin made by aluminium. So at the same time that we can understand the textile here, we can understand also with the materiality as a really light material. Here we are trying to bring identity, texture, and rhythm with this project, and not just doing a historical pastiche or copy something that already exists. We're trying to bring here something new to the city. Our next project, called OODA Verticali. OODA Verticali is located in the first ring of Tirana. So it's 1 kilometer, 1.5 kilometer far away from the Skanderberg Square, the downtown of the city. And this project is really complicated when you first see in the first images, but they are a really interesting concept behind that. You can see here through the video that behind we have the sports university. So we thought, while we were doing our project, why not bring the university and open this area that the university has to the public and transform it into a park. Of course, the university will still use in this area, but this is a proposition that we show to the clients, we show to the Prime Minister, and it's something that right now it's under development. So here in the middle of the two towers, we're gonna have this public space in the ground floor connecting to this new park. And we know that Tirana has a lack of green areas. So we thought that bringing this park here will give to the city a small freshness to this area. The main concept here begins with the old word called OODA. OODA means village in Albania. So here it's really simple. It's a vertical village. These towers are divided in two phases. Phase 1, which is the highest tower, and phase 2, the smallest one. The project are with 20 cubes. So the highest tower we have 13 cubes, and the smallest one we have 7 cubes. Regarding the program, we still having this mixed use, as I said, in the Bound Tower, really important to the urban life of the city. We vision this area behind our plot for people that are living in Tirana, but not just this area, but in the top of each cube, we're gonna have a common area for the inhabitants that are gonna live in our group. The concept of the facade and the idea here of the facade is that each cube has his own identity. And his own identity are 100% inspired by local arts, Albanian local arts, vernacular architecture, and materiality that we can see here. Another thing that is really important to talk about this building is that far away this building created a new and singular shape, a new skyline in this region. But when you see in a small distance, you can understand the details, you can understand the materialities, and you can understand the human scale that this project has. About the materiality, we did a big research. We've been doing a big research about the country and the city since 2022 when we received our first commission. And the materiality here, we try to bring all the materialities here from Albania. We are not seeking to have any materiality abroad. And this is not just a marketing thing speaking, but it's an economical and it's a design position for us. The third one, and the last one is Daria, which means split in English. This project is located in a coexistent area with old and new buildings. It's the name of the street is Muslim Shuri, and it's close here. The main concept of this project is to draw first the void. In this project, we're not just starting with the massing. We need to understand how can we draw the void and before doing the massing. Why? Because we did a lot of experimentation and iteration to do this project. And many of this iteration was creating a huge wall in the urban fabric, and we don't want that because the plot is really thin and very long. So we need to understand how can we break this wall that will be created in this area. So we start drawing the void. When we have the void done, we are able to do our massing. Here, drawing the void, we create a lot of balconies in the middle of the tower. So these balconies, as I said before, the lack of green areas here in Albania, we put vegetation in this area that will create a microclimate around the building. But just not in the balconies. In the ground floor, in the middle of this void, we're gonna create a water feature in the middle, bring more freshness to the city. Regarding the structure, we have here this 3D. We have 100% structure made by mixed concrete and metal structure. Talking about the facade, here we did a big research also in the street, in the Muslim street, and we understand that the main color palette it's the brownish color. That's why we try to bring with this bris soleil, this brownish color that we can see in the street. Why we choose the bris soleil in this case? We understand that many buildings here in Tirana have the shadings. It's not just an artificial thing, an architectural thing to have shadings in apartments, but it's part of the culture. So we thought, why not to bring another different type of shading? So at the same time, the bris soleil will cool off the interior of the apartment, will create a new pattern in the exterior of the building. In the middle, to mark even more our crack, our break, we have this metal sheet perforated, covering this whole area. This will be something very interesting because we have apartments, and so with this metal sheet we are able to have more private areas, more private for these apartments that are facing each other. Talking a little bit about the program, here is another mixed use. In this case, we have the hotel on top of the tower, of this right tower. And we're gonna have a huge open view, a sky bar and a sky restaurant with pool and other amenities. This is a few images from Muslim Street. And the relationship between the two towers in front of each other. And this relationship between the existing building, the Tirana Garden building, and our building, which is going to be really close in front of each other. And when we always finalize one project, we came up always with a question. So what's next? What's going to be the next step regarding facade? And we have a research team inside of our office, always researching about new elements that we can improve. And for us, this kind of storytelling that we have, that it's implemented in our facade, are 100% connect with this research team that we have in our office. So this is something that OODA are always trying to search and trying to find a better way to do architecture, a better way to have this relationship between facade and city. And I think, I hope in the next talk, we can have more great ideas and great buildings. Thank you very much.
Thank you, Louis. Great portfolio of projects. I hope they are built to your expectation. Okay, we move to a facade engineer next, Pietro Pavesi. He is from Faces Engineering. Faces is one of the leading facade engineering companies in Italy, working globally. So he's going to be talking about facade engineering consultancy, bridging vision and buildability.
Good afternoon, everyone. So first of all, thanks to the whole Zak organization for having me today. It is a pleasure to be in Tirana after our past experiences in Italy and the upcoming one in Rome next week. So I'm Pietro Pavesi, Associate Director and Partner of Faces Engineering, today with the presentation Bridging Vision and Buildability in Facade Engineering Consultancy. First of all, let me spend a couple of words about Faces Engineering. So it is an engineering company, was born 12 years ago. We are 40 people in the staff, equally subdivided into our main sectors, which are facade engineering, and that's why we are here today, structural engineering, and the site supervision of both facade and structures. Our headquarters is in Milano, and since last year we have opened also an office in London. We are comfortable in working all around the world, and we have the pleasure to collaborate with some of the most important architectural studios in the world. Here we have some examples, for example, the Region Waterfront in Reggio Calabria by Zadid Architects, I'm sorry, or City Wave in Milano by Bjarke Ingels Group. We have also great collaboration with Antonio Citterio and Patricia Viel with many buildings in Milano. This is a tower that I will present to you later. This is the Moncler headquarters, recently completed. And we are also familiar to work in, for example, we have this tower in Bangkok, which has been completed a couple of years ago. As a typical facade consultancy, Faces is common to work with architects or developers, banks, investors, and we can cover the whole design stages, so from contest and competition up to the design stages and site supervision, as I was saying. Linked to this chart, I can link actually the points of the today presentation on the right. In order to do it, I would like to present you two case studies today. On the left, this is the A2A new headquarters in Milano, designed by Antonio Citterio and Patricia Viel, architects. On the right, the Region Waterfront in Reggio Calabria, still in Italy, by Zadid Architects. These two are two deeply different examples. On the left, we have a high-rise building which is fully glazed. On the right, a museum with quite a complex shape, which is almost fully solid. I've chosen a couple of keywords in order to discuss later. For the tower, these keywords were prefabrication and double skin facade, while for the museum, discretization of the parametric shape. Just to let you understand our involvements in these two projects, for the tower, we've been involved since the competition stage, and in my opinion, the competition stage is the one where a facade engineer could help the most the design team and the architect in taking strategic decisions. And then for both the two projects, we have been involved for the whole design stages, and we are actually involved as site supervisors for the facade, so during the construction stage. Starting from the tower in Milano, during the contest was pretty clear the intent from the architect, from ACVP architect. So their architectural intent was to have a double skin facade, which could be performing and well designed. As you can see, the double skin is located only on the southern exposure, while in the north one there is only a single skin facade. Once we won this competition together with the architects, so we jumped into the design stages. We cover all the design stages. And during the design stages is where we had to make actually this double skin working. So we use very advanced software in order to perform CFD analysis of the double skin facade. In the center, you can see a model which is very detailed and accurate of the typical detail of the double skin. The purpose of this CFD analysis was actually to understand which were the maximum temperature inside the cavity and to check the compatibility between this maximum temperature and the serviceability temperatures of the materials, such as PVB interlayer or SGP interlayer or the blinds. Because within the cavity, together with the architects, we designed Venetian blinds with an engine which can work only at certain temperatures. So at the end, the outcome of this CFD analysis was the section on the right, which has been sketched by us, of course. It is a completely bespoke system when you deal with such geometries. So you can appreciate the internal skin with a triple glass, the Venetian blinds, and then the single laminated glass on the exterior. The outcome, I was saying, was to have 7 centimeters of gaps, both in the top part and bottom part, of the double skin in order to allow the natural ventilation. And also with the CFD analysis, we have checked several coatings, the preferred one from the architects, and at the end, only a couple of them were applicable to our project due to the temperatures. The other keywords, if you remember, was prefabrication. So these are some 3D sketches that we, as facade engineers, we use to provide the architects and the client in order to let them understand our intent, our philosophy behind the design. So in our project, actually, we thought to pre-assemble everything, of course, because we are dealing with a high-rise building, so we wanted to avoid any kind of scaffoldings. So our project was based on the assumption to have a pre-assembled module, which is the internal skin, a pre-assembled module, which is the horizontal one, which is called the catwalk, which is also meant for the maintenance of the facade. And finally, the last pre-assembled module, would have been the external skin. After having completed the design stages, we jumped then into the construction stage, where Faces is actually involved as site supervisors. In Italy, it is called Direzione Lavori. That means the site supervision is a legal, it has a legal role, a legal responsibility, because on behalf of the client, we have to check the compliance between the project specification and what the contractor are proposing. The facade contractor for this project is Focchi, the Italian company. They are doing an amazing work. We assisted them through the whole process, starting from the visual and performance mock-up, as you can see on the left, and then to the installation process, where we are active every week in drafting site reports. One thing I can tell you, which was an optimization brought by Focchi with respect to our project, is the picture on the right, because they wanted to push even more the construction sequence and to compress the construction schedule, and so they decided to pre-assemble the whole double skin facade in only one piece. It is something absolutely amazing and technological. As you can see, the box, it includes the internal skin, the external skin, and the horizontal elements, which are the catwalks. Lastly, another aspect that we use to cover as facade consultants is the maintenance of the building, especially when dealing with high-rise buildings. So on the left, there are some 3D models that we provided during the design stages in order to check the eventual interferences with MEP ducts, with the staircases, and so on. So at the end, we define this kind of rails that you can see. And a couple of months ago, as site supervisors, we've been to the ATEC factory in order to see for the first time the machinery that in a couple of months will be brought to the rooftop of the tower, and so we assisted to the BMU testing procedure. Switching to the other project, which is the Regium waterfront by Zadid. As I told you before, in this case, we were not involved in the competition stage. We were appointed as facade engineer starting from the schematic design, and our first reaction was actually about the envelope. Not easy at all. Because as you can imagine, it has a parametric shape with double curvatures. So our first approach was to try to understand the envelope, defining up to 14 facade and roof typologies. And with our parametric department that we have in-house, we have supported Zadid architects in studying the envelope, because once again it has double curvatures, so not easy. We studied the whole envelope. In here you can just see a small portion that we have analyzed. And by means of parametric tools, so Rhino, grasshoppers, and bespoke scripts, we came up defining as you can see on top right, the final panelization or tiling about the cladding, which in this case are hexagons with different dimensions, of course, in order to be according to the position that they have on the envelope and on the double curvature surface. We also assisted Zadid architects in trying in doing an optioneering about the different materials for the cladding itself, from ceramic cladding to glass cladding, cement. But at the end, we moved for a construction point of view to aluminum cladding. So we started designing the system actually. So these are all 3D made by us on the curved surface of the project. This is a construction sequence that we have assumed. The envelope actually has a standing steam system for the air and water tightness performance. And then in the middle and on the right, you can see the bespoke brackets, which have to be bespoke in order to be adjusted on the curved surface. All these processes have been shared with a couple of possible suppliers. We used to collaborate, of course, with them because given the complexity of the project, we always want their feedback and possible optimization. The construction sequence is completed by the aluminum cladding, which they have the hexagon shape, as I was saying. And as you can see, the system is capable to adjust and for all the angles of the project. Of course, we have prepared a full set of drawings, of 2D drawings. In this case, you can also see particular details on the rooftop, where we also took care about the rainwater collection. And once again, as in the case of the tower, we thought about the facade maintenance, so something quite, let's say, hidden, as the architect wants. By concluding, of course, all the design process has been supported by our structural team. We have calculated the hexagons, the metal cladding, both in the cases if they were perforated on the left or solid on the right. And let me just conclude with these two pictures, because as I was saying, we are actually involved as site supervisors. While the tower of A2A will be completed this year, the region waterfront works are starting in 2026. So this is a picture from Google Earth of a few months ago, and below the rendering actually. And so I hope to see you next year with telling you which will be the facade contractor, and maybe with some pictures from the building site. Thank you. I saved 2 minutes. Thank you.
Thank you, Pietro. So this is what facade engineers can do. They can bring value to an architect's design. Okay, our next speaker is Ferran Figuerola. I hope I pronounced it right. He is from a firm called Cricursa. Cricursa are a specialist in curved glass, jumbo glass products. They are part of the Tivitec group now. So he's going to be talking about glass as a canvas and glass as a sculpture. Over to you, Ferran.
Very simple. So this is afternoon. I could give you a very technical presentation. I thought, no, let's put a lot of pictures and talk about what people think glass is not. People think that glass is transparent, has no color. Obviously, we have to apply solar control, insulation. It provides all the technical. The facade is one of the most important parts of a building. But it can also be a canvas, and we can use it. We can use it as a sculpture. For all the rest, you already know, so I don't need to tell you anything. So we start with the easiest part. This was a project that I thought we would never build. This is a hospital providing public service, public healthcare. I thought they are spending too much money with the facade. This is not going to be built. I told the architect, I'm losing my time with you now because this is not going to be built. And he said, you have no idea about the hospital business. The price is fixed. All we need is people to come to our hospital, maximum occupancy. And if we care with the facade, people will think that we will care with their health, which is true. People will go to our hospital, they will not go to the neighbor hospital. So we want to do a very nice facade. Obviously, this is the simplest way of applying design on a facade, which is doing a ceramic frit. So this is a white ceramic frit. Obviously, in front of every room, there is this glass with a frit. But the frit is very simple. It's the typical traditional frit, which is a screen print. There are 5 different types of glass. And we designed a nice frit that is transparent in the middle, or very transparent in the middle and more opaque in the rest. There are other ways. We can have gradations of the frit. These are very simple ways. This is a project in Seoul. So we have a spandrel with 100% frit, and then from 100% it goes to 0%. These are easy ways of applying frit. But nowadays we have digital frit. With digital frit, we can apply a different design to every single glass. So now we are starting to use a huge facade to be able to apply the image that we want. It can be this, which apparently is a random image, but it's not. If you see, there is continuity from one glass to the other. So here there are as many images as glass units are in the building. Or another project also in Paris where it's the same thing. No, it's every glass is a little portion of an image. And with digital printing, we can do this very, very much affordable. The glass, of course, has solar control. It has sound insulation. It has thermal insulation. But it also provides aesthetics. It's a huge canvas for you. You can think, okay, no, I choose this glass from this company, this coating from this company, this, but you can do many more things apart from just choosing what the industry is giving you. You can give something to the building, and the processor can apply your idea on the glass, because the glass is a matter of design. This is one of the design, a closer look to what we were seeing here. No, so you have two ways of applying frit on a glass. One is the look you want the building to have, and then you must think about the closer look, which is also important, and which is different. It's a two-scale way of thinking. Or another project. This was a building for, actually this is the microscopic image of a skin cell applied on the building, because the company inside is dedicated to analyzing skin cells, all right? This is a project in Liverpool, in the UK. Apart from the frit, from the design you can apply with the frit, we can think about what inks are we using. We could use white or whatever inks, or we can use metallic inks or even mirror inks. In this case, we are using copper, gold, many different things. And we can also have something that looks one way from outside and a different from inside. For example, this. This glass is white from the outside, but it's black from the inside. So this is the same glass. It looks opaque from the outside, but in reality, it's transparent because the black is allowing vision through. So there are many buildings that you see they are white, but in reality, people from inside, they don't see them white. They look through the glass, because all this glass, which is this is a huge building, Telefónica building in Madrid, the glass looks white, but it is black from inside, okay? Same thing, another project also in Madrid that apparently looks white, but in reality, the glass is very transparent from the inside. You don't have that opaque look. But in the past, we were looking at buildings, and we were not seeing our building. We were seeing the building in front because it was reflecting. With this, you can see your building really, because you apply something, a filter on the building, and you see the building. You can give color if you want. This building is done exactly with the same technology that we saw before, but with a different approach. Here, they did not want it to look white, but it's also white to the outside, black to the inside. The white is for sun protection. And as you can see from the inside, it is very transparent. We can use frites. It's not yet a thing here, but it will be someday, to protect birds from crashing into the building. This is Google Campus done by big architects and Hedderwick. This glass has little things on it that help prevent birds from crashing into the glass. We can do this with this system, and there are other systems, many different systems that are not visible for human eye. I will not go through all of them, but I can tell you that if you want to avoid birds crashing into the glass, you can do things on the glass, all right? And then I will show you something which doesn't look like glass. This, apparently, it's a stone. It's not a stone, it's a glass. This is also not stone, it's a glass. You could even have LED lights from at night, and the building changes absolutely at night. This is a very new thing that's starting right now. Or this. You could have panels that are 5 meters or 3 meters tall. It's difficult to find a natural material that can provide this size. Other things that we can do, we can apply color, okay? Crazy colors, yellow, orange, red, blue, yellow. I think we have to avoid thinking that glass is transparent. Glass, yeah, it's transparent. All these are transparent, but they are colorful things, okay? Zaha did project in Beijing with purple glass, crazy. 3,000, this is apart from applying color, we could combine glass with other materials, like this is a metal mesh for the LinkedIn offices. I don't know if you have a LinkedIn profile, but where they have these glass fins with a metal mesh placed inside. We can modify the scale. We can do things which are very large, 9-meter tall glass. We can even curve it to avoid having vertical mullions. This is a project in Hong Kong with 9-meter glass tubes. So the scale changes. And you can have a big opening with glass. And then we can use glass as a sculpture. By curving it, we can make very large buildings and give them very good, perform very good against wind loads, for example. This was a project in Calgary. These are two very nice projects in New York. Only by curving the corner, we are already doing something, but we can curve everything. We can have a flat facade with a lot of curved glass. Now here, it starts having a big expression due to using the form of the glass. Glass we can play with the glass. We can form it many times. For example, this is a refurbishment. We added that big part at the top on an existing building with this curved glass facing outside. But we can do other crazy things. For brands, for example, Nike in Fifth Avenue, they have this specially designed, specially made for them. They are not afraid. They are like the most innovative, so they want very innovative glass. Or glass can be structural. If you know how to play with this is a Hedderwick project, Bombay Sapphire. I don't know if you like gin, but this is where they have the little plants that put in the gin. Every glass is one shape and providing the strength and helping support the structure. Or as I had it project in Beijing, in Hong Kong, with huge. So the building becomes a sculpture. Okay, and this is the last thing we did. So we are playing so much with the glass that actually I don't know if you can see, but this is Sagrada Familia, the cross at the top of Sagrada Familia. This has been 4 years of investigation trying to develop something for that little part of the project, and this is it. Thank you.
Thank you, Ferran. So these are the possibilities with glass. You can play a lot with glass. They no longer are flat surfaces. Okay, our next presenter is Akis Valalis. He is the founder and general manager of iBuild. They are from Greece. They are a glass processor and they do fire-rated glazing. So he's going to be talking on facades and building envelope, thinking outside the box to accommodate architectural needs and visions. Over to you, Akis.
Hello, everybody. Can you hear me well? Great. Thank you for the opportunity of being here among such great company to present what actually we can do. We are a facade company, also not only glasses, but aluminum and anything that has to do with the envelope of a building. Let's go first. We're just going to present two cases, two actual problems that were given to us by the architects that we were supposed to find solutions to. The first one was a project that we did in Cyprus, in Limassol. The architects were Mosesur from Israel. And they wanted not to have any type of roller weave on the outside of the building, especially at the parts of the facade that was fully glazed all the way to the top. As you can see, the building is a fairly typical skyscraper. It's the Ritz-Carlton Residences. It's a mixed-use apartment and hotel in Limassol. And the two east and west facades had a lot of glass that if we were supposed to use the not laminated, but tempered glass on the outside, the architects were afraid that we were going to have a roller weave effect when looking from the side of the building. So, especially having more than 260 projected out windows that we were supposed to make as step units and to have a perfect aesthetic appearance on them. When the mock-ups were ordered, we had the idea of using, instead of the solar control Lowy glass on the outside, as it is the normal, to put it on the inside of the double glazed unit. On the outside, we used the laminated glasses, and this created a very nice, different effect when looking at the facade on the outside without losing a lot of performance. I will show you here, hopefully. There we go. No. Keep holding. Okay, there we go. So the first data sheet from the normal way of dealing with this was supposed to have a solar factor of 33. The change that we created by using the solar control glass on the inside made us lose about 7.5% of the G value of the composition, even though the glasses were the same. This created an increase to the annual energy demand of about 3.5%, which was within the tolerance that the architects had allowed us to have. This is where the mock-ups were set up in Greece, because we were at the COVID period at the time, so it was not easy for them to come and see. We had a special firm that took excellent videos and photos. They sent it to them, and we managed to create something that they liked. On top of this, because we used not a tempered glass on the outside, but a laminated one, a clear laminated one, we were allowed to make the stepped units without any ceramic frit that it was so nicely presented before from Krekusa, but without any ceramic frit, but just with a silicone that we were supposed to adhere this to the aluminum window on the back side. And you're going to say, okay, why, so what? Is this an advancement? Is this something? No, but this created approximately 15% savings on the total cost of the facade. And the architects were happy with the appearance. The developer was very happy that he saved some money. And this is the end result of how the Ritz-Carlton Residences looks in Limassol. And we hit two birds with one stone just by just by thinking outside the box and doing something that's so simple but so effective. Let's pass on the second one. This is a building in between Manchester and Liverpool in England. We were commissioned by Metka, Mytilineos actually, to create in the administration building a corner full glazed facade that it was supposed to house the offices and some very special equipment inside. The demand was on the fourth floor to create an area that was fire rated EI 120. And for a facade, you know that this is a little difficult. And we had to combine both systems, both the fire rated system and the conventional stick by aluminum, the M7, in order to have uniformity in the building. What we did is, first of all, we took the fire-rated part of the facade, and the limitation was that we needed to stay below 3 meters height for the glass panes there. Otherwise, the rating, we could not get the fire rating. So we designed the whole building using the 3 meters as the standard, as the given. Problems. First of all the floors had different heights. So this made the building look a little, let's say, funny. We used spandrel areas to eliminate this phenomenon. And on top of this, when we arrived at the fourth floor, as built, we saw that the cement on the backside was not enough to create the fire compartment that we needed in order to enclose this. So the solution was to design a steel skirting that you can see here that was supposed to go on top of the existing slab and little parapet that they had, so that we can have the whole 3-meter area that we're going to make the compartment in completely enclosed and have the ceiling that we needed with the spandrel parts above and below it that were non-fire rated. Second problem, the columns, the steel columns of the fire-rated system were completely different in the width from the aluminum ones that we used in the other part of the building. This meant that we had to have different brackets, and also, given the fact that the fire-rated glasses were about 150 kilos each, we had to have a very strong support for the fire-rated part. Oops, sorry, let's go back. This is the skirting that we used. This is the elongated bracket for the non-fire-rated part. And then on top, you can see the detail that we had a metal portion protruding out in order to support this glass that is actually 7 centimeters thick, including the solar control panel on the outside. Needless to say that also the front thickness of the two systems were not the same. That was corrected by leaving a little bit more space, though, in between them. 99% of the time, solutions exist as long as we're willing to think outside the box, open-mindedly, and go out of our comfort zone in order to challenge ourselves, and then the results, if successful, they are really fulfilling. Best wishes for a great convention. Thank you very much. And I was very fast, I know. Thank you.
Thank you, Akis. They have a booth outside, so if you want to discuss anything with him, look at their solutions, you can meet. Okay, our next topic is completely different from what we've had today. We've always had everyone talking about beautiful buildings, new build projects, but you still have an existing building inventory here in Tirana from the Soviet era, which needs renovation. So Anna Vesho, who is from New York, is going to be talking about facade restoration, balancing modern high-rise development with maintenance of existing housing blocks in Tirana. It's a completely different topic. Again, they all have facades. They need refurbishment. So she's going to draw some parallels from what is in place in New York City with their code and how that can be implemented here on projects in Tirana.
Thank you. All right, good afternoon, everyone. My name is Anna Vesho. I am Albanian, but I live and work in New York City. I'm a building envelope consultant, and I work exclusively in facade inspections and facade restorations. I will talk about my work, and I will introduce you to one of the most stringent and comprehensive laws in the United States with regards to facade safety. I'll talk about the legal framework, regulations, and I'll also show you a case study of its application in New York City. And then I will share some of my views on the complex issues that we see in Tirana regarding balancing modern high-rise development with maintenance of existing housing blocks. Let's get started. I have a lot of ground to cover, so I'll try to keep it brief. The current facade safety regulations in New York City are based on a piece of groundbreaking legislation for the time, and it was first enacted in 1980. And it all started after an incident involving a falling piece of masonry, which struck and killed a student walking down the street in Manhattan. So this gave birth to Local Law 10. Then more building collapses brought forth the need for upgraded rules, and the facade inspection safety program was born in 2010. The acronym is FISP. FISP categorizes buildings in 3 designations. So we have a SAFE, SWARMP, which stands for Safe with a Repair and Maintenance Program, and Unsafe. Unsafe meaning that there are hazardous elements in the facade that need to be repaired as soon as possible. And these conditions are determined by a qualified wall inspector. New York City's FISP, this is a mandatory inspection and reporting system that requires all buildings over 6 stories to undergo comprehensive exterior wall examinations every 5 years. So it's not every building is a certain type of building that classifies for this inspection. Once the inspection is complete, there's documentation, then the compliance process. As I mentioned, we have 3 designations, SAFE, SWARMP, Unsafe. And the Department of Buildings, which is part of the local government there, receives the report, reviews it, accepts it, and then issues a certificate to the owner. And this must be displayed in a public area for the public to be informed of the classification of the building. It's similar to those. If you've been to New York, they have a food inspection certificate posted on the outside the restaurant. So it's kind of similar to that. The ultimate goal for the owner, of course, is to have a safe building. If the building is classified as swamp or unsafe, then mandatory repairs need to be conducted to bring the building into compliance. And the way that they enforce this is, of course, money. In order to enforce compliance, there are penalties that are applied to the owners. There's a $1,000 monthly fine for failure to file inspections on time. There's a late filing fee for submissions after the deadline. There's additional fines for buildings with unsafe conditions lacking protective measures. And there's also compounding penalties that increase the longer non-compliance continues. There is also this document which has been put together by the Department of Buildings, and it's aimed at the inspectors, but also building owners or anyone who is interested about learning more about conditions affecting facades. It's a long document, and they start with brick because it's the most common material in New York City. We see many type of deficiencies here, cracks, spalling, defective mortar joints, and there's a description that tells you what to look for and what the possible causes of these defects are. Moving on to terracotta. This is ornamental terracotta. It's another common material. This terracotta can fail in different ways, such as surface cracks, spalling. There's a picture here that, it's this one over here. You can see a missing section of terracotta that, I'm assuming has fallen down. So I hope nobody got hurt. That's one of the dramatic ones that I've seen. Terracotta, these buildings are about 100 years old now, so it's only natural for us to start seeing these conditions with terracotta buildings. Then we have more examples of facade defects, balconies, corners, a cavity wall veneer. Here on the bottom, we see another dramatic example of how that veneer has failed. It's a quite large section, wall section. This is rare, but we do see it, unfortunately. And usually the cause has to do with the anchors, the brick anchors that tie the brick veneer back to the backup, either missing anchors or corroded or improperly spaced anchors. Then we have some glass and curtain wall defects. You see broken glass, issues with the trim, deformed mullions. These are also common. And in many cases, these defects are also tied to issues of water intrusion. And we see this with brick and terracotta too. Many times these conditions are connected. Whenever we see cracks on the facade, that's just another opportunity for the water to get inside. So when we work with these buildings, we are addressing both safety and sometimes water infiltration. There are this guidelines are based on American standards, the American Society of Civil Engineers, and the American Society for Testing of Material, or ASTM. And then I want to show you a case study of a recent project that actually is still in progress. I've worked on this building, and I just want you to see the application of this rule. This building is located in Manhattan's Upper West Side. It's a facade restoration project, and the materials are limestone at the bottom. We have brick in the middle and terracotta at the top sections. The current FISP status is unsafe, and it is also a landmark building. This is a map of showing the location in Manhattan, and it's part of the Landmark Preservation Commission Historic District. And this is the historic designation report. These are all public records. It shows that it was built in 1911, 1912, so it's over 100 years old. With this being a landmark building, it means that there are even more rules that we need to follow regarding regarding the restoration and the materials, methods used. The Landmark Commission requires that all replacements to be done in kind. So we had to use terracotta for replacement. We can't rely on alternative materials that are sometimes cheaper. Here are some photos from the cycle 9, which is the previous cycle. These are from 2022, and there are some close-up pictures of, so the inspector went and conducted a close-up review and found multiple conditions, but these are just some of them. There's significant cracks and other problems with terracotta, especially. This is a street facade, so we pay close attention to that because the public is more exposed to that. And then another document that we prepare, and it is submitted to the DOB, is this. This is a facade mapping, and it basically goes into detail, documenting the location of everything we see. So here we have a list of all the problems that we see in this building, and they also have a tag here indicating where the problems are. So here we look at the 2 street facades and then the back of the building, which is all brick. It's the street facade that was it is more. We see more ornament here. This is important because it informs the Department of Building and the owner where the problems are with the building. And then an architect is hired or an engineer to help design the repair program. And the ultimate goal being that that we have to bring the building to a safe status. So now we move on to the construction drawings, and this is what it looks like for us. This is a snapshot, but we are responsible for addressing everything that the report mentions. And more. Sometimes when we do close-up reviews, we often do notice many other issues that are not mentioned in the report. So we make sure that our project really really brings all of the building unsafe conditions into compliance. And on the right, there is a list of the scope of work, and that is just the terracotta portion of it. We had a lot of terracotta replacement in this building, so it was quite an extensive project. Then this is a detail from one of the Juliet balconies on the Main Street facades. Here we have all the units here, terracotta units at the bottom that need replacement. And I also included this section here where you can see we're highlighting some steel behind the terracotta here, and I just want to say we did not do any probes, we didn't open any probes in this building. So really, these are kind of an assumption, really based on previous experience, similar types of projects, buildings. And of course, in the field, we verify all conditions, and sometimes we do get surprises, and that is why we include allowances in our scope for any surprises. Next, another moment I want to talk about is this. Another challenge is really defining the geometry of the units. Sometimes it's hard. Here, for example, we weren't sure if the unit 10 there was a separate unit, or was it part of that block above? So we had to confirm that. You know, it's very important that we are very thorough with our drawings and details, because we don't want to be replacing more units than we have to. You know, it comes down to cost and time and schedule. So it's really all connected. Then we have mobilization. So now we have the contractor that it's been selected, and we have mobilized on the street facades. We have suspended scaffolding, and then you see me there on the right. I'm doing a close-up review of the shoring, and that is after a large piece of terracotta has been removed, and we need to support the dead load of the facade above. This is the 10th floor, I believe. So there is some dead load there that needs to be supported, and this is part of the contractor's responsibility to install this, and make sure it's safe during construction. Then there are more conditions that we see after we go on the scaffold and we go really close to the building. Now, it is part of the FISP guidelines that if the inspector sees an unsafe condition and it can be safely removed, then they should do so. And that's what you see there on the picture over here. And you can see how large this piece is, and imagine, you can only imagine the force that this would, how fatal this would be when it hits the ground. So unfortunately, this it's not uncommon to see this condition. And then we move on. There's more reporting. So only because we are doing repairs, it doesn't mean that the building is safe. We have to keep reporting. The Department of Buildings needs to be informed of each step. So here we see a before and after. That's why it's very important to keep track of the locations, because if photos are unclear, they do return our reports back to us until we provide the right documentation. They pay close attention, especially to terracotta, because it's considered a risky material. And then, you see we have replacement at the Juliet balcony that I was showing earlier. Then we have more replacement at the water table and at the facade. So this is the last slide of my case study, and I tried to show some practical examples, and I'll move on to now Tirana. In Tirana, we see a very different urban landscape. We have rapid urbanization under communist rule. Residential housing blocks consisted of mid-rise building with taller developments emerging later, and common materials were brick and reinforced concrete. So fairly simple construction methods compared to what we see in New York. Some common sites today, and these are just pictures I have taken during the last couple of days, just walking around. I'm sure those who live here are familiar. There's this additions, facade alterations that were very common in the older communist era buildings, and this type of work took place in the 90s, 2000s, where we have individual owners that were trying to extend their interior living space by doing this sort of adjustments. There is also a lack of maintenance work, and I cannot help but notice this and think that all of these conditions are technically unsafe by New York standards. There's a lack of uniformity in construction materials and methods, and there's also questionable workmanship and detailing. I have seen, though, that there is some work being done. I've noticed, many buildings have there's repairs being done, so that makes me a bit more hopeful. And then with the major high-rise developments, they're certainly advanced in terms of materials and systems, but in my opinion, they highlight some future challenges that the owners and local industry will be dealing with. We see new materials, glass, aluminum, incorporated into facade systems such as curtain walls, window walls, rain screen systems. We do know this from experience. In other countries, we have proven risks associated with these types of wall systems. We have sealant failures, gasket disengagement, anchorage failure, glass breakage, condensation, water ingress. These are all risks, to name a few. And there's a variety of reasons why we may have these, but it's very important that they are caught and addressed on time. And this is where legislation becomes imperative. Another aspect is the height of these buildings. I'm curious to see, how we're going to be dealing with serviceability, accessibility, how maintainable these buildings are. And I've noticed there are legislations in progress to address some of these issues. But today I've shown how we've dealt with these issues in New York City. There are some lessons there. So whether aspects of that regulation can be applied here depends very much on the approach that the local authorities will take. But there's always something to learn. thank you. And, I hope you enjoyed and learned something. Oh. Thank you.
Thank you, Anna. Now we'll move on to the last panel discussion of the day. It's on the Skanderborg building, the building which you can see outside. I'd like to call upon Carlo Zacca from Alca Aluminium. So he's going to be leading this panel discussion.
Yes, and then, okay, so good afternoon, everyone. Thank you once again to Zak, the Zak team, and Ahmed for having us here today and for finally coming to Tirana. Today, we're going to talk about cultural identity in facade design with a case of Skanderborg building. They're already coming. So here with me on stage, we have Stavros Gargaretas, Senior Associate at MVRDMI on my left, the architecture studio behind this project that we will see in a bit. Raniel Sulay and Enea Bedo from the investor side, respectively, project manager at Vind and architect at ANA. And my last but not least, my dear colleague Elvi Giaggio from Alca, which acted both as facade contractor and facade consultant for this project. Before starting, I just wanted to say that I'm very glad to be moderating such panel. Firstly, because this was my introduction to the industry, actually, and to Alca. And it ended up being a very collaborative environment, reason that we are all here seated today to discuss about it. And, but above all, because this project, it's something that you will rarely see anywhere else in the world. And I think it's one of the reasons that made Zak come to Tirana, but also it's represent what Tirana is today and what Tirana will be in the next 5 to 10 years. I'm not going to talk more because we have plenty of visuals and content to give you. So I will leave now the stage to the panelists that will take you through the full journey of this project, from vision to execution, touching elements such as how we went from an architectural vision to a buildable geometry, or how the investors took that vision and turned it into reality, as well as how the facade solutions were developed through mock-ups and custom engineering. Stavros, stage is yours.
Thank you very much. Can you hear me?
Yeah.
Okay.
I think so.
Thank you. It's not intentional that the architecture and the technical client is on the other side, I promise. I don't know why it was set up like this. But just to start, I will give a bit of a kind of concept overview. So I know it's a very technical conference. But somehow, I promise it becomes more technical on that side. So it's nice to first understand a bit the concept, where we come from, and contextualize it before we go into the solutions. I think that's interesting. Of course, many of you might be from Tirana, many not, but Albania changed a lot in 1992 after the communist regime fell. This kind of Enver Hoxha regime, and suddenly the country was left a bit, let's say, after this kind of totally isolationist society. Suddenly it was left without, or not without an identity. It's a bit long to say, but somehow it was looking to find itself and to step and to understand who are its neighbors and how to connect to Europe eventually. And that's a discussion that's happening a lot now. And of course, a lot happened after this fall, and change started happening also around the 2000s, when it's the you don't see the full slide, but essentially around 2000, the current prime minister, Mr. Rama, became mayor. He started off as Minister of Culture and eventually became mayor and now prime minister. And something happened, and people things started to change here. And architecture and the city became much more of an art project than just a technical project. So art and architecture started to come together. So quality. How to look at the kind of old buildings and reinterpret them, and to how artists gave color to the city. Public spaces started to form out of the kind of leftovers of what was left. So suddenly public spaces brought people together in the city. The old river, which was a complete dump, suddenly became a beautiful space to visit, and now you see it and the liveliness that it brings, and of course it's growing and extending. And just to show a bit the context of where Albania came from, and where change happened and where it's going towards. And of course with this change also comes densification and going upwards. And that's a big part of why we're here to discuss facades, is because as we go up, we also need technical solutions that can absorb this kind of heights, this kind of ambitions, let's say. And of course, there were different plans on how to densify. In this case, in 2014, this is one example where a kind of very strict series of towers around the main square was planned out, but nothing like that happened. In reality, actually, what you see in Tirana is that the city is a collection of different, we call it the Tirana collection in our office. It's a collection of different architectures, each with their own character. Each of them want to say something, and each of them want to give a certain identity, not only to the building itself, but also to the place, to the country. So suddenly this Tirana collection is much more interesting than these generic towers that you see happening all over the world. And suddenly that gives character also to Albania, to Tirana, and it also gives opportunity for these kind of buildings to exist, which don't exist in other places, or they try. So this kind of opportunity also has led to this kind of potential to expand upwards, and has led to this. This is work in progress, Tirana, and the building we're talking about is, I don't know if I can point, not, oh. There you go. The building we want to talk about is this. You see it now in this photo in scaffolds, because it's a few months ago, but today the scaffoldings have come down. So this Tirana collection is growing. A lot of buildings are coming. A lot of facade discussions are happening. A lot of experts from outside are coming, and that's partially why we're here also with this fantastic conference. And how to give technique and how to make sure that we give knowledge so these buildings can happen in the most efficient way. That's where we are. And of course, in this collection, we have 4 buildings running in construction, and then a lot more we're discussing with in terms of our new buildings. But we're here to talk about this building here. Maybe the most figurative one in Tirana, at least for now, the one that shouts the most, and the one maybe that discusses. We've had a lot of discussions about this building because its location is, it cannot be more central, right next to Skanderbeg Square, this beautiful square that was renovated in 2017 by the Belgian architects. And suddenly it's a square named after Skanderbeg, this kind of heroic figure. And also a sculpture of Skanderbeg is also found in that square. So suddenly the location of this building is so related to the square. So what do you do here? How can you react to such a strong positioning? How can you give identity within this growing collection that's happening around us? And of course I want to show a bit the background. I know maybe it's less interesting on a technical level, but it's interesting to then go through the technical layers to the construction part. But we started, of course, to explore what is the most interesting project here. Is it a simple volume with pop-outs? Is it a kind of rock form with balconies all around? Or do we become more figurative? And I know the jump from before to this is huge. And I can talk on hours on how we got here, but this relation, this new figurative monument linked so much to the square, linked to this figure, this Skanderbeg bust, a sculpture, an art piece grown up to human scale, which is what started happening actually in 2000 with the splashes of color on the buildings, art becoming architecture and having a very strong relation. And you see it with all the new buildings coming up. Every building has something to say. Every facade is an art piece, essentially. So we have to, with our facades, also reflect this in our technique and in our expertise. And of course, just to show you simple steps on how this came, this extremely awkward site and plot. And if you make the volume that we were requested, but then if you push this volume to the edges of the plot, and you start to carve it out suddenly, almost like a sculpture, like a marble piece, you start sculpting out this kind of figure, giving kind of this identity but a human scale also to this monument. Because you give, of course, commercial value to it. You have your commercial, your offices, and your residential. But the most important thing is that this element has features, and people have lived within the features of this monument. So you give habitation to a sculpture. And this is a funny video which has not been shown before. It's kind of an internal process. It's an internal Christmas card of the office at that moment when we were designing. But it shows the kind of absurdity of looking at scale in a different way as a sculpture that becomes humanized and you can live inside it. And how can our detailing allow this to come to reality? That's what I want to show a bit in a few steps and give the word then to my colleagues. Just to show you the simple first massing of how the features of this building look and how the human scale of these balconies gives also habitation to this monument, looking from the square, the relation to the different buildings around, and also going around the corner looking at the shoulders as they touch the weird plot, and as the head turns to look towards Scandinavia. So there's so many actions happening here on a sculptural level that somehow when you zoom in, this kind of facade, the balconies all around, they give a really human scale. And that was the challenge, how to achieve this, how to bring this to reality. And of course, the floor plans are efficient, but all of them are different. Everyone has a different balcony. Everyone lives in a different part of this figure. One has a fantastic nose balcony that looks over the square. One lives with a balcony in the shape of the ear of Scandinavia, and you get these beautiful moments in the facade where you actually have a panoramic view standing at the ear of this heroic figure. So you're part of the cultural identity of the country, and it also gives that identity to the inhabitants, but also to the city. And of course, it has to become, from a sculpture, it becomes reality, and these beautiful veins, structural veins that go through. We work with the best local structure engineer, Mr. Ruben, to come to these veins, and it starts suddenly to become reality. That's what you see here. And you see more in this kind of how these features of a sculpture can start becoming structural, how the boat structure starts to hold up these extreme cantilevers, and it works. And it's really fantastic to see it out there and to go close and to even go up. Hopefully one day when it opens, we can also visit it with the crowd before the residents move in. So the facade concept, of course, wasn't simple. We didn't start and immediately have the answer. We went through a huge operation of trying to understand what is the facade detailing that will lead to such a kind of ethereal feeling of a marble sculpture. And we went from solid facade, from more concrete with metal railings on the left, to more bringing glass elements inside, to creating just vertical elements, all of them represented also in a kind of simple section, and going lighter and lighter. And what we found is actually that the lightest works the best to bring this kind of sculpture to life. And I show you here just as a series of images because it shows this kind of exploration that we did, how we start lighting it up, adding glass elements, how we only do it with vertical elements, how we add metal instead of concrete balustrade, and how the metal becomes then aluminium, and then eventually glass with a beautiful gradient. And suddenly this gives us the effect that we wanted. And the challenge was how to bring this effect on a detail level. These are details that we prepared, which were then taken over. It is two simple details, the balustrade and the inner facade. So two elements go all around the building. If you get these details right, that's all you need. And that's what the main challenge was and the beauty of what's happening right now. And of course you see this, the gradient of going from a solid balustrade that hides the concrete slab to a transparent balustrade where you can look through as a resident. That was a big challenge and a beautiful collaboration, I think, with Alka to work that. And you see here a few images from the inside what that would look. And of course, the detailing of the facade had to be in such a way that you read the figure, but at the same time it's doable and it's manufacturable. So that's where you see in plan this kind of 40 centimeter elements that allow a high resolution to get the sculpture right, but also at the same time can be standardized and can be easily controllable on a manufacturing level. That was extremely important. So it's a very complex sculpture that somehow becomes quite simple in its manufacturing. And of course, the integration of the light, which allows for the sculpture to also be iconic at night. That was also an important part of the design. And the last part, and I hand over very quickly to my colleagues, is how this became then a detail and how we started to zoom in to understand these two elements of the railing, the simple balustrade that gives the figure, and the inner facade that makes efficient floor plans. So these two elements together essentially create an efficient floor plan with a very expressive facade. And the in-between space is the balcony. These fantastic balconies that run all around, which you don't get in our days because commercially it's very difficult to add these two buildings. But because it was such a strong part of the concept, this balcony, it gave value to the apartments. And that's what was very important in this building. And of course, how this detail went further, how we tried to tie this balustrade back to the concrete, how we create this kind of raised floor, which now is different. We wanted it raised, but it wasn't possible technically. And of course, the final images that we created before we start going into construction, how the separators work, how we have the same kind of technique to create the separators. We're still doing mock-ups for these, we're not finalized. And finally, how the fragmentation of this complex facade also works for the flooring. Also a technical exercise we had to do on each level. And finally, the balustrade, how transparent do we want it? How solid do we want it? We went through a lot of iterations and gradients on what is the best for hiding, but also in creating the shape as solid as possible, but at the same time allowing for visibility. So these are just screenshots of our process that I'm showing you here. All the specifications, and finally the last renders that we handed over to the client, essentially to go into construction. So after this, you see the constructed element. These are the last images that we produced with the exposed concrete, with the correct route for all the aluminum profiles, with the correct gradient, and you just see around, just to give you a bit of a walkthrough of the last image. And zooming out, of course, how the sculpture suddenly creates kind of spectacular urbanism in this collection of Tirana. And of course, now there's more coming here, there's more coming here, there's more coming here. This image was made maybe 2 years ago, and suddenly the city is already requiring a lot more in terms of high-rise. So I stop here, giving a bit of a more conceptual part. I hand over now to yeah, thanks.
Hello, my name is Raniel. I'm the project manager of the building. We took over from MVDRV the beautiful design that you already saw. And the first challenge was to understand what was required in type of materials and the final product, what would be. The project manager position was difficult in order to arrange between the investor, clients who will buy the apartments, and architect. On the other side, to find the proper contractor which could give the solutions, or if I can go further. Yeah, so what we started the work, it started from this initial facade and balustrade renders. So this was the initial drawings that we took over. And not to be very technical, but in all the building are executed 10,000 square meter of facade and 3.6 kilometer of balustrade. I say it in kilometers just to understand better if you put it in a linear to understand what volume of work is done on the site. So from these renders and drawings, then we had this detail that also Stavros explained earlier for the balustrade. Critical for the building was the balustrade solution, because the facade was somehow done before and was, let's say, understood from the investors and possible contractors. We as investors, we had firstly to evaluate the possible contractors to include in the project, and also that could be able to give the final product as required. So we had some parameters to evaluate them, contractors to evaluate by their previous similar projects, capacity to check, improve, and detail the initial design, capacity to make the implementation and production design, and capacity to produce and install the facade at the required quality and time. Also, the final one, which is also important, is the financial offer. The idea is that this building, to us and to many other investors in Tirana, is very specific and was not something very general. So by evaluating the possible contractors, we took 3 main offers: Alka, Alumil, and Helti, which was in cooperation with Shuko. The facade, these are the first mock-ups of the facade, and then we had the mock-ups for the balustrade. After evaluating all the parameters that I mentioned earlier, we made a decision to go ahead with Alka, seeing some projects that Alka had done before, like Toptani, like Lakeview. So we had the previous experience also with Ring Center, with working with Alka. So in the part of the construction, firstly, we took the documents from the architect, and from these documents, we had a review with the offer from Alka. So technical data sheet, drawings from Alka, so how they could fit with each other. Then the second step was the preparation of mock-up, because it was very difficult for us as investor and also to have the understanding and the agreement from the architect that the product was correct, because we could not go directly to production only from the drawings. So we had a phase of mock-ups for the facade, for the accessories of the facade, for the balustrade, and also for the separating element between balconies. So we had the mock-up phase and also a final mock-up phase, let's say, mostly to decide the color and the finish. Then all the work, let's say, was given to Alka to start with the production drawings. So after the mock-ups were done, I think was before the mock-ups.
Oh, yeah.
Is
They're
previous?
in Elvis part now.
They are in Elvis
Yeah,
part.
we
Okay,
switched.
sorry.
We gave it away
So
now.
as idea of the process was mock-ups, agreeing on the mock-ups, then we started with the execution of the works. This is the first element of the facade being installed. Then is the first element of the balustrade being installed. Then during the work. During the work, here you see half of the building being done with facade and balustrade, because also the crucial point was they had to go in parallel in order to remove the scaffolding. Because of the shape of the building, the scaffolding was also a very specific work to be done in parallel with the facade. And this is a photo during the night to implement also the lighting of the building. This is all from our part as a client.
Hello, everyone. I'm Elvi from Malka, technical director, and I'm explaining now the technical part of how this facade has been done. First of all, the 2 points of this project was the internal facade that Raniel said it was simple, but it was not simple. And the most important, the glass balustrade system that serves as the primary element through which the building takes the shape. The first one, the internal facade, after we see all the plans, we saw that there were a great variety of angles from 90 degree to 180 degree, both positive and negative angles. Also, there were a lot of cases when we have the balcony door that we have non-uniform positive angles and non-uniform negative angles. For this kind of lot of angles, we started with a study of all the angles in order to secure all the joints to don't have problem also with air and water infiltration. So we started creating new profiles, since new pressing profiles, new gaskets, and new
customized.
It was a lot of part customized for this the internal facade. And then the most important was the changing of the glass balustrade. There were 2 points. One of them is to achieve the required geometry. That also it has a variety of angle from 70 to 180 degree, both negative and positive. And also to meet the structural stability and to have a fast installation. That was one of the requests. For the fast installation, we have some discussion also with Raniel at the early phase, before the building coming up, that here don't happen every time. And our proposal was installing the half-fan profile. Thanks to our persistence and Rani's persistence, the investor approved this. And after approving this, we start to find. This is as you see.
Hold.
Okay. The anchor that we installed at the concrete works. And also this has been installed every 40 centimeters, like the requirement of the architect was for the balustrade. It was very important, this part, because we saved time from installation, about 40% only with this element installed already on the concrete. Then after we go on with the anchor, our next challenge was finding a supporting bracket system that allow us to make it also to connect to the half-fan and then to be adjustable in all direction, X, Y, and Z, because everyone knows the concrete has its own irregulation and it needs to be adjusted. I have made a video in order to explain how it works. It was the bolt that goes on that goes on the Alphen profile, so that can be, excuse me,
just once.
That can be adjustable in two direction, and this was the bracket that can be adjustable also in Z direction, rotated, and mounting of the mullion with these bolts, and then go sequentially with the other elements. This is an illustration of it is this balustrade realized. The other thing was in order to find how we connect the element to each other in order to achieve the geometry that the architect wants, and to be also, for this we find a solution creating a rotating bracket that allow the rotation 70 to 100 degree, both negative and positive, and it can be installed, that we installed also at the top and the bottom rails. Also we have an illustration for this, that this is the bracket that allow the rotation in different angles, and coming up with the other rail, so, and then putting this screw up. This was the most important things, that bracket, and also that allow us to achieve that geometry. Another thing that was very important is because of this was totally a custom systems, we have to test it, and we make a test in laboratory for the static load and dynamic load. Also with the architect present. After we have the conclusion of the test, we go with the massive production for this. Then the other part was also, that is also important, the glass. We made, as the request of the architect, we made 3 types of colors. So the architect decided also it is color and gradient, like the shape they asked. This is what we have done now. This is from that technical part. I think we achieve what the architects want.
I think we have a video that sums it up.
And here is if Carlo then can go on.
No, this is, yeah, we don't need that anymore. I mean, this is basically a visual recap of what everyone just said from the beginning to the reality. It's some different point of view thanks to a drone to see how it looks like and how you can see the different shapes that the human face can have depending on where you're looking at it. And I think that everyone touched very important points. So I think we all have an idea of, let me remove this because it looks quite... I think we all have an idea of what it took to, build from a concept, a very raw concept, something like this. So since we have a few minutes left and we are in a panel, let's make it a bit more interactive. So I have some questions for you guys about this project and about what you said. Starting with you, Stavros, you talked a lot about how Tirana changed in the last 20 to 30 years, which we all can see that. And considering also this topic of, cultural identity in facade design that was definitely applied to a project like Skanderbeg building, and considering also the work that MVRDV is doing in this market in the last years, do you think that this kind of project is something unique to the project itself and to the context, which is Tirana, or do you think that it can be somehow replicated in other contexts?
As a system, you mean?
As
a
a whole,
figure, of course not. It's
yeah.
a very local.
I think you have to put this up a bit.
Ah, yeah. Okay. Well, first of all, thank you for showing the technical difficulties. I tried to explain that it was a very standardized system, but it was not always transparent to us, the complexities. But it indeed it translated very, very successfully. But talking about your question, we were lucky, or not lucky, but the opportunities here, I think, are quite special. Also talking about this kind of post-communist moving into this new renaissance that Albania went through was really looking at architecture differently, looking at architecture and art as a new thing, a new relation, not trying to replicate, but trying to give it identity, and also looking as a country for identity, and for looking towards Europe in these new negotiations with Europe. These kind of projects start to give a historic value. So architecture and history and culture come together, and I think that's what the country is looking for also. So you kind of want to not necessarily to show what you are, but somehow to bring this identity through your urban form. We were lucky also. We worked with a client that gave us the opportunity to do that. I mean, I'm not sure we would do this in Germany. I'm absolutely not sure we would do this in Germany. I'm not even sure we would do this in Greece. So there's opportunity, and clients are open for these kind of discussions. Of course, also on a upper level, the government kind of sees this kind of growth as important, as an important part of growth. So yes, this place allows these kind of projects to come to life. This is something that probably would not happen somewhere else, I think, now at least. And I think specifically this building on Skanderbeg Square, looking at kind of the square and the importance of Skanderbeg as a figure is, of course, very, very contextual. So to answer your question, yes, of course, the idea could be replicated elsewhere, but this project is extremely specific, and it came about because of these kind of opportunities that happen here, because of looking for identity, because of clients that are open for this discussion, because of technical solutions, as you saw, that allowed it to exist. So the research that Alka did to come to this is almost off-grid. That you went off-grid, and this maybe doesn't happen in other countries, to be able to go so off-grid, non-standardized, start to go to Italy together to specify, to make sure that we can give classification to the material. So all of this off-gridness somehow is also what allowed this to be extremely specific to this place. And if I answer your question.
Yes. I mean, there's no correct answer or not. That's valid. I perfectly agree with you. Actually, it's something that is core to what we can call the Tirana system, if I can use this word. And I think this cannot be replicated in beautiful and historical cities like Paris, Rome, or Vienna. But definitely it's part of what Tirana is trying to build and is already building somehow with projects like this and many, many others. Going into, let's say, more of how this vision was brought to life, because sometimes getting from such a abstract vision to reality takes complex challenges. So wanted to hear more from Raniel and Ea. The question is open to both of you. What were actually, more than one for sure, hardest challenges that you had to face, and how did you handle them in achieving what was the desired outcome by the architect?
So initially, the first difficulty was from the investors, because those are the guys who pay the money, and the investors in Albania are not used to this kind of facade and detailing. They are used mostly with standard buildings. This type of building, the facade, has a huge cost for the investors. So the first challenge was for them to understand and accept that this building is not the standard one. So it required the upgrade or update of their mentality. Secondly, it was the difficulty also from our side technically, because we were not prepared for this type of solutions. So the best thing was the cooperation between architect, investor, technical, and also Alka as the contractor. Without this coordination between all the parties, it would be impossible, or we would have another product for which none of the parties would be happy. So
it was not always smooth.
It was not smooth, for sure. It was not smooth.
It was compromise.
Take and give all the time. the involvement of ALCA from the initial phase, from the concrete works, really helped us a lot. So that half an anchors, Elvi mentioned it as a small technical detail. But to us as investors, it gave, let's say, minimum 6 months of reducing the timeline of the project. And I also mentioned to my colleagues, without that, we would have 100 workers there drilling the concrete to make that balustrade. So also challenges were during the construction for the safety, because working at height, double scaffolding, everything was very difficult to educate the people, the workers, to give this product was not easy. And we had many times to stop them, take their time to understand what is that we require to do. Also coordinating every month, every 2 weeks with the architect, because something on site to us was correct, but we needed a second eye to cross-check it and to say, yes, you are on the right path, go ahead. We had the situation with the balustrade. We were agreed that, okay, it was fine, the glass color. When we installed 100 elements, we saw it was not the right one, so we made the change. So it happens.
I remember
but the coordination of the parties really was, I think, was a good experience for all of us.
Yes.
And the final interventions, because I'm the technical part. I don't hate architects, but I don't like them. So
hence the separation.
This was a constant.
So the idea is that we were working very fast to achieve the timeline, because at the end, my scope was to finish the building, because the investors want as soon as possible the clients to go in. So then the architect comes and he says, look, I want to change the position of the LED light.
Yes.
That was just everything
challenge.
stopped.
Another challenge.
Another change. Another challenge, yes. So, and it was not a minor change, because to find the exact position, to find the proper material, then ALCA to implement again the change of the socket for the LED light and everything, to me as a project manager is 4 weeks of delay, this much money of extra cost. For the architect, the product is very nice, and everybody was happy.
That's what's going to be left. So.
Yes. So we had this back and forth pressures between us, but I think the process went smooth and went very good.
Yeah. So basically, you're saying that it was a mix of 3 elements: the right budget, which I mean that's of course needed in every project; the right timing, which sometimes it doesn't happen here, like that. You know, for the facade especially, sometimes a building is up and companies call you, and that sometimes it's too late and they want to rush. So doing that earlier definitely helps and should be a common best practice, like it happens in bigger markets and more developed markets. And last but not least, organization and requirements and rules since the beginning. I think we had a very good approach as a one team that helped a lot in achieving this, outcome.
One thing that's very important for the investors in Albania, because we know the investors around here, mainly in the beginning of the project, they fix a budget, because it's difficult to understand what will be the cost of the final product. And what they do during the negotiations is that in order to keep the budget, they reduce the scope. So we have 3 glasses, we make 2. It's okay for us as investors. In this case, I'm very happy that the investors were open to comply with the requirement from the architect and with the offer from ALCA.
Yeah.
Otherwise, it would have been another product.
Absolutely. Definitely agree. Yeah. Enea, you want to add something on this? Or?
Yeah. In my point of view, I may add it was challenging to furnish the site with all the drawings necessary for, let's take in consideration the half an acre that is put every 40 centimeters during the concrete works. And we had to take, to follow the schedule, so not to lose any time in furnishing the site with all the drawings. When I put every one of each element in the entire project, and let's say it's not a project where the typical floor exists.
Yes.
None of the floor is the same with another one.
Sure.
Also this was a bit challenging.
It's a problem of the architects.
Which is the quality of the...
Good. I think we are running out of time, but I have a question also for you, Elvi. Since you developed lots of custom solutions, what were actually the key moments or key decisions that were taken with the investor and with the architect that made you say, okay, we're going to build this and it's going to look like what Stavros wanted? So,
look, every project we take, it's difficult. We don't take standard projects. It's our phase that we do what others can do.
Okay.
At first look, it seems very difficult, but thanks also to the collaboration, also Raniel was a good point that support us and also explain our solution to the clients. So thanks to this collaboration, after we finding a solution with the Alphen, we then understand that it can be done and it can be done well. And after this, also in this case, we also do test of the balustrade. That was very important, and we was secure what we were installing. Also, and after all these phases that were at the early phase, we were very secure that we will do and we will achieve what the client wants and also the architect require.
Yeah, I agree. And I think mock-ups, since they were done a lot, were key to satisfy everyone and, go with the flow without many interruptions.
And it's not super common here to do mock-ups always. So the mock-up was the most critical part, actually.
Yeah, actually it was kind of the core of the early stages to do mock-ups, and I think that
also,
helped.
in this case, one of the, not every time happen here that we discuss in the early phase after the building was coming up. And this was very important because when the building comes, we were ready with this solution, and then we can go
build
on
some strategies.
Yes, with building strategies, and we can go on with the installation.
I have the
and
feeling,
everything goes as we planned.
Just one thing to add, because in Albania it's not so common to have it's a facade conference, so that's very relevant. To have facade advice early on is not common here. So we do a design, and at some point that design is taken by the client to kind of to procure it, to give it to a facade consultant, and so on. If I think this should be earlier integration with facade experts from the beginning, because that will save a lot of time, I think, in later phase. And we try with a lot of clients to do that. Not all the clients understand it, because they say, no, when we get to the technical design, we'll find the facade consultant, he will do the project. But then it comes too late, and then we run into discussions. In this project, it didn't cause a lot of delays, but in another project, it's causing a lot of delays. So if you're a facade company, the number one target should be how can we get in on the early phases, just to make sure that there's a close collaboration with a design from an early phase, because it will help us, it will help also the quality, it will help in the end the execution and so on. I think that's also for the client, for you to discuss.
Yeah, I think we said different stuff, but they set up some very, let's say, common points regarding, the timing, the organization, the alignment, and all these elements put together to achieve the best possible outcome. I say we close it here. We have some red flags in our eyes. So thank you everyone for joining this panel, and hope it was interesting.
Thank you. Thank you. Just a second, just have a seat. So I'd like to thank all of you for attending today's event. I hope you enjoyed today's event. We tried to curate something which is as local as possible for Tirana and Albania. I think what we have established from today's events is that there's definitely a lot of potential for Albania to grow. There's definitely a lot of scope for facade engineering. Facade engineering is literally not present here, or it is at a very, very nascent stage, which means that there's a fabulous amount of possibilities that can be had if, as Tavos said, if you get your facade decisions very early in a project. And I think also our panel has demonstrated that a complex building of this shape can be executed in a place like Albania, which means that with limited resource and with expert guidance, they've been able to execute a project like this. Many more such projects are going to come. I think the future is extremely bright for Albania, and I hope you guys enjoyed today's event and had key takeaways. I always believe an event is successful if you can take away one thing from it. Of course, we've had 15 talks and 2 panels today, but even if one thing, if you've been able to take away from this event, I think as an organizer, we are extremely proud of contributing to that country, to that region. So thank you all. Until we meet next time, we have a networking reception, so the drinks are going to be passed around. So we'll have a photo session with the panelists, and then we will come and join you out over there. So thank you all, and hope to see you whenever we organize this event next. Thank you.